Good morning, everybody. Thank you so much for joining our conference. We are not complete yet. Some people are still searching the entrance, but we will start anyway because we have a tight time schedule and we want to end in time so that we can still have some drinks with you after the ending of the conference. First of all, I will introduce myself. I'm Laurien Spruit. I work for Bellona Europa. I'm a senior policy manager, and my specialty is the industrial policy in the Netherlands, Belgium, and North Rhine-Westphalia. And that's also in this framework of this work that we are organizing this conference. First of all, our director, Jonas Helset from Bellona Europa, will take the stand and will welcome you all. Thank you so much, and I wish you a very nice conference.
Thank you, Laurien. And indeed, welcome everyone to this conference. It's nice to see that the room is filling up. You never know these days how it works out when you have a conference that is not a hybrid one, but we actually try to make people to come here. And the purpose of doing this is to bring together people from different countries, sit down together, speak together, and network. And I think we all know that being physically present in the same room makes a whole lot of difference in that respect. So, my name is Jonas Helset, Director of Bellona Europa. I'm going to say a few words for those who don't know Bellona that well. Of course, we would like to think we are famous around the world, but in many ways, this region where we're working now is a region where we haven't been established for that long. It's an environmental NGO, climate-focused NGO, I would say, also in the last 2 decades. Founded in Norway 35 years ago. Now international, working in a set of countries, Europe being the main focus area for our regional work. And industry has been one of the main areas topic areas that we're working on here in Brussels, in Germany, in Netherlands and Belgium now, and in the UK, and of course in the Nordic countries where we started out. I'm going to say a few words about why that is. Industry, I think it's fair to say for those who have been following the climate action debate in Europe the last decade, industry has not been a top priority. And I would say in some ways, when it comes to industrial decarbonisation in Europe, we can even call it a lost decade. There's been way too little happening. And there's been a lot of blame games going around for that. But I think we need to move beyond that. We need to think about how we actually change that, and we have no more decades to lose. So, from our perspective, having worked on this first in a country like Norway, where you could say it was a natural starting point. Norway, for many people, is a place that has got a very green image, a very climate-friendly image, but it has a higher CO2 emission per capita than Poland. And a lot of that comes from being a small country, quite a bit of industry, of course there's the oil and gas industry as well, quite present, and a lot of shipping and other emissions. So those have been the areas that we focused on, while many people in particular here in Brussels were looking at the power sector. But industry, steel, cement, chemicals, the chalk industry, or lime as it's often referred to, are industries that make up about 20 to 25% of EU emissions. In some countries, it's even higher. And in this region, or if we can call it a region, it is much higher. So how is it that this has been outside of scope? Industry, some people say it's complex, it's complicated, it's difficult. But of course, that's exactly why we need to do something about it. And I think there's been a tendency in the climate change debate to say that industry is, it's been a problem and it needs to be shut down or needs to be phased out. But the industries we're talking about here are the building blocks of our societies. They're welfare-carrying industries that are also key pieces of the green shift. We're not going to get any wind turbines without steel and cement. We're not getting passive housing without cement. We're not getting passive housing without a lot of chemical industry to provide the input for that. So we need to think about how we can make that industry part of the future, and how we can make sure that Europe is a place where our industry thrives in a carbon-constrained environment, and actually becoming part of the solution to net zero emissions. One of the things we learned from the work is that because of that extremely important aspect, which is about the jobs and the welfare that these industries are providing, is to bring in also those people who work in those industries. On the EU level, where I've been working the most, we have high-level decisions about climate, about targets, but often those decisions are not well-founded in the places where they will have the biggest impact, on the ground, where the jobs are, where the industry exists, and in the clusters, of course, where they will have a much bigger impact than in other parts of the Union. And that is also something we see often reflected on a national level. And of course, if that is the case, then you very quickly turn not only the industries themselves, but also the unions and the workers into opposition to climate action. And I think if that's the case, if we end up in a place where unions are out on the street protesting climate ambition, there is no win anymore. There's only a lose-lose situation. So we can't let that happen. Why are we focusing on the Netherlands, Belgium, and North Rhine-Westphalia? I think it's clear that, of course, this is one of the biggest industry clusters in Europe, if not the biggest, when you combine them. It's also one that is quite well interconnected, but mainly interconnected when it comes to what we would describe as the problem. Fossil fuel infrastructure, linking them up. But that also, in a way, provides a good starting point for connecting them on the infrastructure that enables us to decarbonize. And that is what we need to do. We worked a lot on the EU level, as I mentioned. We've been also very active in the EU technology platforms for different climate technologies, the Zero Emission Platform focusing on CO2 infrastructure, the ETIP bioenergy focusing on bioenergy, of course, biofuels, solar panel technology platforms, etc. And some of you might remember the NAR 300. It was a big funding scheme that was set up by the European Union to address emissions on large scale, renewable, innovative renewable projects, CO2 infrastructure, etc. Very little came of that, and there was some clear learning that we were able to draw from that. We worked with the technology platforms. We also did our own analysis together with partners across society, across the economy. And one of the clear outcomes of that analysis, which also is recognized by the European Commission, was that it was focused on big, long-standing projects. It was not thinking about clusters. It was not thinking about collaboration, and it most certainly wasn't thinking about collaboration across the borders, which you would think also is one of the main purposes of the European Union in this respect. So that has led to some helpful changes. We got traction on the trans-European networks for energy, looking into widening the scope towards CO2 infrastructure. We have the Innovation Fund, which is much more focused on that type of, at least enabling a cluster type model. But there's a long way to go, and this also has to be bottom up. And we need to get not only some ownership, but we also need a clear agency in regional and national authorities to actually come with projects. Because otherwise we're stuck in that game where the Commission says there's no interest in member states, there's no interest in regions, and there's no interest in industry. The countries will say the same, and industry will say we get no help. And we get nothing. So we're starting to break that inertia, but we still need to work a lot harder, and we need to do that together. So that's understanding of clusters and hubs and how that is part of the key to the solution here. That goes for every part of infrastructure that we need: electrification, grids, hydrogen, CO2. System thinking is key to this, and system thinking is necessary on the European level, potentially beyond in some cases, because that provides a foresight that helps us think about what type of infrastructure we need to invest in now to enable the outcomes we need 10 years from now or 20 years from now, and also enable industry to make the investment decisions that they'll be locked in with for decades. That doesn't mean we're going to have a crystal ball, and we don't know exactly what industry we'll have in Europe 10 years from now or 20 years from now. And industry doesn't know that either, I think. But we have some basic understanding of what are the no-regrets infrastructure investments that need to be made in order to start a dynamic that we've failed to generate the last decade. That turns into accelerating that infrastructure and also recognizing that regions are different. Some regions have different starting points. Some regions have access to CO2 storage. Some regions have a lot of renewable potential. And if we don't work together, we're going to fail to bring this along in a European context, which will create an unlevel playing field. And I think that also leads to crunch time and stop of climate ambition if we don't manage to make this work for everyone. So that's a just transition in Europe. And I'm going to end this on a positive note. This sounds like a very difficult thing, as I said. Many people think it's difficult and therefore also politically don't touch it. But in fact, we can turn this into a win. I had a pleasure 2 weeks ago to sit in a panel with the energy minister of Alberta, Canada. And Alberta is not the region that comes to mind when you think about climate action. There's a lot of things you can say about Alberta, but in that context, they're known for their tar sands and massive oil and gas infrastructure. But they also, therefore, are quite familiar with infrastructure and comfortable with it. And they made those investments a decade ago that now make them the place that industry calls. They want to invest in that place because it's a place that de-risks investments for the future, because industry knows that we need to go to net zero. And that means that if we in Europe manage to make those investments in the right places, we can actually turn this from a rush to the bottom to a rush to the top. So that's where we need to be. And I would like to thank our NGO partners who helped us also in building this momentum. It's nice to see that we can do this also from the NGO side, not only have a conversation that's either driven by industry alone, governments alone. We need to work together. So I would like to thank our partners in Natur Miljø, in Bonn-Beter Leefmiljø, Clean Air Task Force, and German Watch for collaboration, and welcome again, everyone. Thank you.
So I just have a practical thing to say, like the speakers, you can take your seats in front. It's easier if you come and give your presentation, so you don't have to do it now, but after the break, please be welcome to sit in front. I'm very excited to announce the next speaker because it is Jo Bruins, the Flemish Minister of Economy, Innovation, Work, Social Economy and Agriculture. The minister is very busy today because he's launching a stronger policy against illegal employment, but we're very happy that he was so kind to record a video message for us. And maybe first a bit of explanation about Belgium, because this is the Flemish minister. As some of you know, we are a political complex country. Like, we have 4 ministers, one in Brussels, one on the federal level, one in Flanders and one in Wallonia. Jo Bruins is the Flemish minister, and so also in Flanders is the port of Antwerp and the port of Bruges and so on. So that's a very important region for industrial decarbonisation. So I'm very happy to announce Jo Bruins, the next speaker.
Beste deelnemers, beste organisatoren. Jammer genoeg kan ik vandaag niet aanwezig zijn op deze conferentie. Maar met deze videoboodschap breng ik jullie toch graag een kort woordje over het Vlaams beleid rond industriële decarbonisatie. Ik hoef jullie er niet van te overtuigen dat in Vlaanderen de basisindustrie belangrijke hoekstenen zijn van onze economie en dat de steeds verder klimmende CO2-prijs onze bedrijven noodzaakt tot broeikasgasvermindering. Ik hoef jullie evenmin te vertellen dat de actuele aardgascrisis steeds harder op de pijngrens duwt. De economische en ecologische prikkels stuwen in dezelfde richting. Het is daarin de uitdaging om een goed perspectief te houden. Begin 2019 lanceerde de Vlaamse regering dan ook het Moonshot-programma, waarbinnen methoden worden onderzocht om tegen 2050 op industriële schaal een CO2-arm alternatief te kunnen vormen voor de huidige processen. Hiervoor werd er nadien een contextanalyse en roadmap-studie uitgevoerd, waardoor we nu een kijk hebben op de mogelijke technologieën voor onze basisindustrie. En bij gevolg ook een traject voor wat onderweg naar 2050 nog moet gebeuren. Voor mij als minister van Economie is het cruciaal dat we een realistisch beeld hebben over hoe onze economie er in een klimaatneutraal Europa zou kunnen uitzien. Ik verwacht dan ook van onze bedrijven dat ze in ruil voor economische steuninstrumenten kunnen aantonen dat ze ook effectief die transitie aan het voorbereiden zijn. Voorbouwend op de contextanalyse stelde mijn voorgangster Hilde Krevits een Vlaams decreet voor dat een gestructureerde aanpak van industriële decarbonisatie wettelijk verankert. Het decreet werd dit voorjaar goedgekeurd en momenteel stelt men een eerste programmanota op. Zo is er een governance vastgelegd waarin we alle spelers kunnen betrekken. We hebben een permanent overlegorgaan met de betrokken Vlaamse administraties, de sectoren, werkgevers en werknemers. In een klankbordgroep met onder andere de NGO's gaat het bredere draagvlak in de samenleving moeten getoetst worden. Het is daar dat de milieubeweging het ambitieniveau kritisch kunnen uitdagen, wat ze overigens met grondig studiewerk zullen doen. Het is de bedoeling dat de governance rond de industriële klimaatsprong erover waakt dat andere programma's consistent het traject van de industriële decarbonisatie bewandelen, zoals programma's rond bio-economie, die nieuwe grondstoffen kan aanreiken, rond waterstof als alternatieve CO2-vrije energiebron, rond circulaire economie, waarvoor kunststofrecyclage een hele logistiek zal moeten opgebouwd worden. En zeker belangrijk is een realistisch pad voor koolstofarme energie tegen een aanvaardbare prijs. Want uit de roadmaps weten we dat ook elk scenario, hoe dan ook, meer energie-input zal vragen. Als Vlaanderen kunnen we dit allemaal niet alleen. Voor nieuwe processen en een opschaling gaan we over de grenzen moeten samenwerken. Een mooi voorbeeld van grensoverschrijdende ontwikkeling is trouwens het waterstofnet, een Vlaams-Nederlands netwerk van bedrijven dat sinds 2016 met Vlaamse steun bouwt aan de waterstofeconomie van morgen. Nog crucialer is de internationale samenwerking rond infrastructuur die stapsgewijs zal moeten uitgebouwd worden. Vlaanderen is altijd een doorvoerland geweest, een efficiënte schakel in een hele keten. We staan voor de uitbouw van nieuwe netwerken voor CO2, waterstof, elektriciteit en waterstofdragers. Samenwerking over de grenzen en een gemeenschappelijke doorkijk naar 2030 en 2050 is absoluut nodig opdat investeringsstappen effectief gezet kunnen worden. Grensoverschrijdende samenwerking is ook een sleutelwoord om daar voor Europese financiering vooraan te staan. We mogen tenslotte niet vergeten om intra-Belgisch gecoördineerd samen te werken. Zo is het federaal niveau verantwoordelijk voor de regulering van energietransportnetwerken. Het is voor mij als minister van Economie en Innovatie en Werk noodzakelijk dat we de toekomst blijven voorbereiden. Zeker ook nu met de huidige energiecrisis. Die toekomst zal met steeds minder fossiele brandstoffen zijn. We staan voor een enorme transitie. En alleen door samen te werken over de grenzen heen kunnen we deze uitdaging winnen.
Okay, the next speaker will also be joining us online. That is Thomas Wijns. He's a senior researcher at the Brussels University, and he is specialized in industrial policy. And he will talk about why we actually need industrial policy, why it is so important to reach the climate targets, and also link it to the European targets and the Green Deal. I'm happy to announce Thomas Wijns.
Good morning. I'm Thomas Vins. I'm a researcher at the VUB Brussels School of Governance. It's a pleasure to present our work on the industrial transition and on cross-border cooperation between regions and countries to achieve climate neutrality by mid-century by industry. What I want to present today is some recent thinking on how industrial transition can take shape, but also the challenge of multi-level governance for the decarbonization of multiple industrial regions. With the VUB, we've been doing some work on industrial transition for various organizations and governments. Particularly, we did some work for the Flemish region on a roadmap for the industrial transition. But we also worked on EU level with regard to the policies and measures that we need to get there. The thing I want to convey today, there are two things basically. It's that we will need a three-level thinking on the industrial transition. From basic mitigation technologies to the energy industrial transition symbiosis to thinking about a materials energy system. The second part of my presentation will cover the challenge of multi-level governance for cross-border cooperation in, let's say, the industrial heartland of Europe. We all know this industry, basic materials industry, it drives society, and it drives modern society from steel to make buildings, to make cars, for fertilizers, pesticides, for food production. Plastics are driving an enormous diversity of value chains with all its problems and solutions. And of course, one of the major consumed products in the world is concrete, also with a lot of greenhouse gas emissions. If we look at the impact of industrial activity across the world, I see direct impact of industry with regard to its emissions and its processes is around 18–20%. But if you would add the indirect use of heat and electricity on top of that, industry is by far the largest emitter of greenhouse gas emissions on the planet. Looking also a bit to today, the current situation we're in, the major energy crisis. And if we look back at the industrial production in Europe, and here you see on the left side the production volumes normalized to the year 2000, we see that in the economic crisis 2008, 2010, all these industries received a major hit. There was a demand crisis. And that's logical, that's what happens in an economic crisis. But what we also noted is that it left scar tissue, that most of the industries, except for the chemical industry, which is the top line above, never fully recovered from the crisis. And this is a bit of a warning sign for what we face today. If we lose industrial capacity through the energy crisis, it's possible we will never see that capacity return again in Europe. On a positive side, what we also noted is that industry is already shifting, having a fuel shift away from solid fuels to more natural gas and more electricity and some bio-based inputs. From all the research we did, what is the current state of the industry with regard to decarbonization? We see that there's a lot of breakthroughs happening. A lot of technologies are coming online or are going to come online with deep mitigation potential. But it took a while to develop these technologies. It's not like a new iPhone which you get every year. This is something that might take a decade or longer to get fully at the highest technology readiness level. We also see that we will move to higher levels of electrification. We hope for a virtuous cycle between renewables and industry. I'll come back to that. Circular economy will be important. I'll come back to that too. And industrial symbiosis, and hopefully new business models will emerge from this transition. So the level one, if we purely look at mitigation technologies and techniques, this is an older slide, 2019. We more or less know what the basket of technologies is going to be. It's going to be electrification of heat, mechanical, electrochemical processes, the use of hydrogen, carbon capture and utilization, biomass use, and carbon capture and storage. And of course, energy efficiency and circular use of materials will remain very important. You'll see across these sectors, the emphasis might be different. With more access, we think the chances of applying something like the technologies above might be higher. This was 3 years ago. What we currently see is interesting that some of these industries are going in a particular direction. For steel, we see that hydrogen and direct reduction of iron ore in combination with, for instance, an electric arc furnace seems to become a dominant technology option for the future. What we also see is that the electrification of industrial heat is becoming a thing. A recent announcement by BASF of an industrial heat pump of more than 100 megawatts is being planned. That's something we didn't expect a couple of years ago. Another element, and that's again linked to the current situation, is that the war and the fossil fuel dependence is urging economies in Europe to cut that fossil fuel dependence. And this means that we will be seeing sunset industry facing the reality very soon. I think, for instance, of crude oil refining. If we see an acceleration of electric vehicles, of buildings moving to heat pumps, to electrification of heat, this part of the industrial sector in transition might face some hard choices very soon. Second level, energy and industrial symbiosis. In the history of industry and industrial revolutions have often been triggered by a change in energy vector. Think of coal leading to the railways driving the steel industry. Think of oil driving the car industry, the suburbanization, the development of zillions of petrochemicals and plastics, and think of electricity, electrification driving the whole IT revolution, internet, and what else we have seen. We think, and it's an educated guess, but we see signs that it's getting stronger, that the renewable energy transition will also be driving an industrial transition. And why is it? Because, of course, for industry that is going to electrify, it will reduce the indirect emissions. We see industry being very interested in green power purchase agreements, or to greening their power supply. We see higher attention of industrial demand response, and in particular, right now with the current energy crisis, industrial demand response is almost obligatory happening due to prices. We see industry thinking of storing energy in materials, and sometimes even reversible as a battery. And we see the option, of course, due to the huge volumes of renewables that will be installed, that there will be new value chains in Europe that become very important. So we might see the creation of a virtuous cycle where the energy transition powers the industrial transition and vice versa. Why do we see these signs? Take, for instance, the example of offshore wind on the left. There is humongous potential of offshore wind in Europe. We're just starting to tap into. There is a potential, techno-economic potential of 6,000 terawatt hours, which is twice the current European power demand. And there is this EU value chain of hundreds of companies delivering parts of the installation, doing the installation, delivering IT resources for offshore wind. So this offshore wind could become Europe's shale gas. And again, the link with industry is there because recently, again, BASF is just investing in offshore wind. It's become not just purchasing renewable, becoming a co-owner of one of the largest offshore wind farms in Europe. Another sign. Or Nearstar, a non-ferrous metals company, creating a virtual battery through its processes. So we see signs that the synergy between the industrial and the energy transition is happening. The third level, energy and material system thinking. As I mentioned before, these basic materials on the left, they drive modern society, and we will need them also for the energy transition. But also these sectors deliver materials to each other. It's all driven by materials, and all these sectors are, of course, very energy intensive. And if we look at it from the mitigation perspective, and here you see the examples of plastic and a study we assisted by material economics. The thing you should look at on this slide is the gray part of the bar on the right, and then the unabated route of plastics production. And the gray part are the emissions associated with the end of life. And everything which is not gray are emissions associated with the production. So if by using all these fantastic technologies, CCS, CCU, hydrogen, electrification, and so on, we will only cut a small part of the overall CO2 footprint. We will only be able to cut the associations of emissions of these basic materials significantly if we deal with the end of life. And that means circular economy, that means technologies to recycle, that means better managing the lifetime of products and so on. This should become an integrated part of how we think about the industrial transition. And also from an energy perspective, it has an advantage. So look here in this slide, in particular in the middle of the three bars, the circular economy, and then on the right you see 3.5 etajoules. So that is the expected energy demand for that route, while the business as usual would be 5.5 ETA-Joule, or the current situation 2015 is 5.2. And all the other scenarios where we said invest a bit more or focus a bit more on new technologies will be higher, or when we focus a lot on carbon capture, we'll also see a higher energy footprint. So transition will require dealing with these materials, including their end of life. And this will require new instruments. Currently, the major instrument we have is the EU emissions trading system, and it's very good at giving a price signal at the point source, but for the consumer perspective, it does very little. I look at this Coke bottle. Yeah, if we have a 100 euro per ton CO2 cost, the price of the bottle would increase by 0.5 cents. So that doesn't give a signal. And you can do this for other parts. For a car, it would be a 1% price increase. For a building, a 0.7% price increase. So we need a broader basket of instruments to deal with the complete chain. And we need new business model. I'll skip this slide a little bit. So what is it? We need innovation. We need a strategic alignment of the EU energy and industrial transitions. We need, of course, adequate finance mechanisms, because some of these new processes will be high capex. We need support for higher opex in the meantime. We need strategic infrastructure planning, because increased power production, increased hydrogen use, CO2 capture will require new infrastructure. We need smart regulatory instruments, a new market for low CO2 products creation. And of course, we will need to protect industry in the transition period. So we've tried to visualize this. Is basically a 5-point star, where we will need to focus definitely on innovation, circular economy, creating lead markets for these new low carbon recyclable products, making sure that our energy and industry system are coupled on many levels, planning, policy, but also on modeling. And the current climate models being used for policy don't include materials that much. We need a new model that also has the material streams really embedded, and we need to scale up, of course, investments across these value chains. You can read about this more in a report we wrote a couple of years ago. So repeating, business as usual. Yes, mitigation technologies roll out important. We need to have this industry and energy symbiosis, but foremost, we need a materials and energy system thinking. Now let's come back to the key topic of today, cross-border cooperation in the industrial heartland of Europe. And it is the industrial heartland. You see that if we look at the maps here, and some call it a triangle, but it's actually a square according to Wuppertal Institute. A lot of the chemical production, quite some steel production, quite some cement production finds itself in this area. And you see an intensity map by the ECOS project also, where all these companies are focused. Below, we see what is basically the most concentrated current hydrogen infrastructure in the world in the same region. And on the right, you see what could be the future, a hub that deals with CO2 capture and sends it to areas around Europe where it can be safely stored. And why is this an industrial hub? Why is this in heartland? Of course, it has to do with the location. Many ports, access to waterways such as the Rhine, the Schelde, and so on. That's one of the reasons. And of course, the history of the regions is itself. So dealing with the transition of such region is what we call a very good example of multi-level governance. And what type of governance levels do we have? We have the local, the regional, the port, the cluster authorities. We have above that the national governments. Above that, we have bi or multilateral cooperation between countries that host these regions. And of course, you have the EU level as levels of governance. And what are the dimensions in which we will need this governance? This requires planning, infrastructure, innovation, overall coordination of the transition, financing, and regulatory coordination. This is from a publication we did a year ago with other universities in Europe. Let me run through all these dimensions. So the planning for a cluster transition. So at the port authority or the subnational level, it's important that authorities and companies involved start with the developing of the roadmaps for these clusters. And most of these industrial clusters in the region have already done that. You need to start planning for the infrastructure that you will need, and you need to start mapping the cluster geography, the outline of where will new or other activities come. At the national level, you need support for overall industrial national roadmaps. You need the development of an industrial strategy. And you need the development, again, of an energy strategy that goes with the industrial strategy at the synergy I mentioned before. Bilaterally, you need a strategic alignment of the planning of linked clusters. It would be crazy that that Amsterdam purely focuses on hydrogen and Antwerp does only CCU and Germany goes for electrification. If we don't have that level of coordination, it will be extremely difficult to achieve climate neutrality in a cost-effective way in these regions. And at the EU level, of course, we need a signal, we need direction, 2050 climate neutrality as an example, an EU industrial strategy, an energy strategy linked to the EU strategy. And of course, at EU level, focus on these clusters, this cross-country collaboration, connecting Europe facility, important projects of common European interest are instruments that could be really important here. With regard to infrastructure for the transition, at the local level, the Port Authority, they have some responsibility to facilitate local hydrogen, local CO2, local electrification. The national governments have the opportunity, the obligation to support that development. Bilateral, of course, means or multilateral means that you will need to coordinate the logistics and start thinking about connecting these hubs with the new carrier. And at the EU level, the same thing, thinking about the new vectors, the policies that go with it, align European policies around it, and of course, make sure, because we're talking about quite capital intensive stuff, that financing lines from, for instance, European investment banks are also ensured to go into that direction. Keeping an eye on the time. Supporting innovation, yes, innovation will still be essential. Quite a few of the technologies we see out there delivering potentially deep mitigation are not yet commercially available. They're at pilot, maybe the demonstration stage. So at the subnational level, indeed, the harbor authorities could assist with the implementation of demos. They could assign development zones for climate-friendly demonstration projects, assist projects with achieving national and EU funding, and of course support brownfield conversion. All sites can be turned into something new and green. At the national level, strengthen the innovation systems towards this industrial transition, support innovation across all TRL levels. We see often a focus on still basic R&D, but we will need to get these technologies out of the valley of that. And that means also support higher TRL levels. And that means, of course, quite a significant financial investment. When it comes to cooperation between regions, what could be interesting could be a cost-saving and a time-saving exercise is to establish an innovation chain. Not every country or every region has to have an electrical cracker demo. It's good that you have one or two, but then of course make sure that you create an innovation chain where that know-how can be distributed across the regions that might benefit from that technology. And then of course at the EU level, dedicated instruments such as the EU ETS Innovation Fund, which is quite a success at the moment and might actually need some expansion in the future. Coordination of activities, another level of multi-level governance, and yeah, with quite some different activities. So for the cluster or the port authorities, the subnational authorities, it could be facilitating of matchmaking between companies. So they have the know-how of which companies are on the sites in the ports and how they could exchange energy, how they could make use of new energy vectors, how waste products can lead to enhanced industrial symbiosis. And national governments could indeed make sure that particularly the energy providers, the TSOs for gas, for electricity, and maybe in the future for CO2, for hydrogen, work very well with the industrial hubs. Bilateral, multilateral, I think coordination is essential. Develop joint positions towards the EU level and reflecting the common needs the mega cluster has. And at the EU level, development, of course, of joint visions, identification of missing links between these hubs and cluster, and coordination of infrastructure networks across the EU. Financing, what are the options here? At the port level, it could help that low-cost leasing of land plots for dedicated climate-friendly production becomes available, and that you, at the local level, really incentivize this type of production through the means you have. National, there are many instruments: fiscal incentives, financial support, assign industrial climate neutrality missions to national development banks, and financially support at the state aid and important projects of common European interest. And bilateral, of course, we cannot develop these hubs and these clusters on its own. We will need cross-border infrastructure. So this is definitely something where cooperation between countries will be essential, not only on financing, but also on regulation level. At the EU level, same thing, enable the financing. I mentioned the EIB before, the industrial project, the important project of common interest, so make sure that there are financing streams available there. And finally, it's an important part is the regulatory instruments. What can a port authority do? I think one example could facilitate low regulatory zones where there is room for experimentation, trial and error for demo plans, that we don't lose time with permitting for a technology that still has to prove its merits. Support companies when it comes to new safety rules for hydrogen, for CO2 or other elements, and that we move ahead there faster. National governments indeed must create the clarity on permitting for new climate-friendly investments, but they can have regulatory financing instruments like contracts for difference, use public procurement to kickstart lead markets, use fiscal instruments, and develop a framework, for instance, for these low regulatory zones for demo plans. Again, regulatory at the multilateral level, this means bilateral, multilateral agreements that facilitate cross-border infrastructure and logistics. We've seen this being a problem in the past, where on one side the permitting is done, the other side the permitting is done, but the connection never happens. This has been an issue with regard to power infrastructure, for instance, in the past. So that's something that really needs to be addressed at the bi and multilateral level. And then finally, at the EU level, then we think beyond the ETS, develop product standards for climate-friendly products. And we've seen that a car will not become that much more expensive if it's made from green steel. Make sure that not only that we have standards for the exhaust and the emissions of cars, but that we also have standards for the materials that goes in these types of products. I facilitate state aid, another example. Make sure that our important instruments such as the ETS ensures a visible carbon price towards the transition. and of course develop mechanisms to avoid carbon leakage. And I think at the moment this is really important. I've shown you the graph of the scar tissue we get in European industrial infrastructure if we are hit with a crisis. I think therefore making sure that the current crisis doesn't lead to permanent closures, it will be important, because we will need this industry to build the society for tomorrow. So my final slide, I think I'm there. What about the future? How will these clusters evolve? What we will see? And I have two quotes, and one is from Niels Bohr, and it's difficult to make productions, especially about the future. So I don't know exactly what will happen. We will see signs about where industry seems to go. Personally, I've changed my mind a couple of times the last 5 years of what choices industry and the clusters will make. The other quote is a bit more hopeful, is Mark Twain's, and history doesn't repeat itself, but it does often rhyme. And I think this is important for these industrial mega clusters. We have these clusters here for a reason. It's due to location, it's due to port, it's due to logistics, it's due to highly skilled workforce. And that has been so in the past. So in the future, we will still see hubs, and there will still see industrial production. But the challenge is indeed to make the production green, to use the new vectors, hydrogen, electrification, CO2 capture, utilization, bring the whole circular economy inside those industrial activities. So it will not be exactly like the past, but it will rhyme with what we're seeing today. So that was all I had to say. I wish I could be there with you in person, but I hope this enlightened you a little bit with regard to industrial transition and how multi-level governance in these clusters could work. Thank you.
Thank you, Thomas. Okay, great. Is there somebody with a question for Thomas? Okay. Yes, you can push your microphone.
Okay, I hope, Professor Wins, can you hear me?
No, he cannot hear you, but the technicians will repeat your question to him.
Okay. Erwin Cornelis from ECOS. Thank you very much for your presentation. It was very rich and, well, it needs some time to absorb all of it. The question I had is related to the policy instrument that could steer that process of change and at European level. And at European level, so in the Industrial Emissions Directive, they embed the transformation plans, which is at facility level. But I also wondering whether we also need some other instruments at a higher level, so for instance, at EU member state level, to steer that transformation. I was hoping that, could you enlighten us on that? Thank you.
I could barely hear the question, but I try to answer this. You asked about additional instruments for the transition and mentioned the Industrial Emissions Directive. I think that's a really good example, in particular because the proposed directive will ask companies to work on transition plans. And I think that is something that is essential, that companies that aren't doing this already will be in big trouble. And we're talking about a transition that will take place over the next 20 to 30 years, which is one investment cycle away. So if as a company, an energy intensive company, you don't have specific plans to get there, you will be in big trouble. So basically what the EID does is ask something quite, it's not simple, but quite necessary from these companies. And it will also give legislators a signal about how ready is industry, which industries are planning to think ahead to invest and which aren't. And if we see a lot of industries or companies not being ready, that should be a big red light, not only for meeting our climate goals, but also for the economic viability and future of these companies in Europe.
Okay, thank you very much, Thomas. We are going to our next speaker. Thank you so much for your inspiring presentation. I'm very happy to announce now the next speaker, who is Steven van Kakenbergen. He's the head of the CO2 program of Fluxys. We already talked a lot about infrastructure this morning, and Steven will tell us more about how Fluxys is realizing this infrastructure.
Yes, good morning, everybody. We are happy as Fluxys to be able to present over here what we are doing in the perspective of the energy transition, and that we will try to share with you in the coming slides. Perhaps to start with, for the people who are not that familiar with Fluxys, who we are. We are an independent energy infrastructure partner headquartered in Belgium, so we can decide ourselves what we want to do. I think certainly in the given circumstances, this can help. It's a group about 1,000 people working in different countries. What we do, we are only a part of the value chain in the energy sector, of course. So we are a midstream energy company. So we transport molecules from A to B, and we are active in different countries, and we operate the assets as shown over here. So terminaling activities, pipeline transport, and storage facilities. So the aim of the program where we are working on with the team is to prepare the company for the energy transition and to become the transporter of the molecules, of the energy carriers of the future. Today we are transporting natural gas. Natural gas will become greener and greener, so the mix will be influenced on what we are transporting today. But the aim is also to develop hydrogen networks, to develop CO2 networks. So I think it perfectly fits with the information that was already shared by the previous speakers. And if we are talking about when we are focusing on CO2, what are the CO2 emissions in Belgium? It's a photo that we like to use because it's an emission of around 100 million tons per annum, so it's a rather easy figure to work with. And there we can see that around 40% comes from industrial activities. And there we need to act, and that's also the role that Fluxys take. We go in close collaboration with different stakeholders, but mainly the energy sector we are focusing on to start the first developments, and also the word cluster, we use it very often. And in the industrial landscape, we see companies that need to move forward in the energy transition, and they can do it by greening their activities. I always say at the input side, for instance, by using green gas or hydrogen, or by applying for carbon capture and greenify the activities like that. So that's also the program that we put forward. We focus on in the first wave on the 40 million emissions, and we propose to the market two developments: a hydrogen network and a CO2 network. So that's what we are proposing to the sector to move forward, and it means that if we look to our network, to our molecule network today in Belgium, it's transporting natural gas. Tomorrow it will transport hydrogen and CO2 as well. So in that way, we can assure energy security to the companies because we will continue to provide the natural gas. We will develop the hydrogen network, we will develop the CO2 network, and the companies themselves can decide at what moment in time they want to switch from the one energy source to the other solution and to be future-proof. Of course, there is there are some technical investigations that we need to perform before switching from one product to another. Is it repurposing, which is a cost-effective solution for both markets, the previous and the new market. Also new constructions will be needed, of course. But if we look at our network of today, we can state that, and over here I can say 100% of the pipelines are repurposable. I always say when my technical colleagues are in the room, they want to kill me when I say that it's not 100, but it's close to 100. Almost 100% is repurposable. We need just to adapt some operating conditions or some smaller interventions. If I was participating to the previous sessions, I heard very important words that come also in our approach. I think it's cluster developments, it's working together, and it's cross-border collaboration. It's collaboration with industry, but it's also collaboration with governments and other stakeholders. And I think all those elements are elements that Fluxys try to put in place. And this is a bit an overview of the process that we are going through. So we started with an information session early 21, because it's often a question on chicken or egg, and there is no infrastructure because there is no carbon capture or no need for hydrogen. There Fluxys proposed some developments to the market, asking to react, to reply on that one, and to share the industry, to share their plans with Fluxys so that we could adapt our initial proposals. And that's a bit the process that we went through in the upper side of the slide. So also afterwards we unified supply and demand, and that's the kind of matchmaking. I heard the word also in the previous speech. And beginning of this year, we published a revised info memo and precise cluster proposals. What did we put in the info memo? It's an approach, a proposition to the market on how we see the first developments. Do we need a regulatory framework? What do we ask for at the legal perspective? Because it does not exist at this moment, but also that is in a very advanced stage in the meanwhile. So I think everybody is progressing, and in the info memo we gave some information to the market, and we asked them, if you want the infrastructure to develop, please come forward. The previous steps were non-binding, and now step by step we are moving ahead to arrive somewhere in the middle of next year to a binding commitment and to push the button and to go for a final investment decision and to put those new networks into reality. And of course, those cluster proposals, I will show later on that we have a plan for the whole country, but the cluster proposal, there we focus on some very precise areas. And of course, those areas are the areas where we find concentrations of the 40 million tons of CO2 that I showed previously. I think it's no secret for the audience in this room that the CO2 emissions in Belgium are in the portal areas. So it's in Antwerp, it's in Ghent, and in the French part of the country, industry is mainly located near to the rivers or near to the the cement and calc industry is where they can find their products as well. So it's also in clusters around Mons, around Charleroi, around Liège. And due to market interaction, we also need to adapt our plans. It's not Fluxys who is going to decide. We are not going to dictate how Belgium will decarbonize. It's an interaction between market policymakers, and we are there to connect point A with B. And that's also the reason why we are going to publish in the coming days an additional cluster proposal for the region of Namur in Wallonia, because industry raised hand and said, you forgot us. It's not our aim to forget somebody. So if the industry wants to move forward, we also develop over there. So there we are going to publish an additional cluster. And also in some other areas, we could also announce some changes. So for instance, in the Mons area, we also published a kind of open season with the French operator, with GRT Gas. With the Dutch one, we announced a cross-border connection for hydrogen in the Zelzate area, in the North Sea port area. So it's certainly a moving target. And I think this is my last slide. This is a zoom on the CO2 map, where you recognize the same clusters. In the north, we collaborate closely with the port authorities. Is it Port of Antwerp, Bruges, or North Sea Port? We collaborate with both. And in the south, you see the clusters. But of course, if you do some carbon capture at your plant, you need to evacuate and you need to get connected with the sinks. So it's not in the CO2 perspective, it's not a question of development of clusters, but it's directly how to connect these clusters with the exit points. And for Belgium, CO2 storage onshore is not on the radar, and it will be offshore in the North Sea area. And therefore we need to foresee some exit points. And we as Fluxys, we are working on 3 very precise projects. I think everybody is aware of the Antwerp at Sea consortium in the port of Antwerp. 6 big chemical companies that joined up in a consortium called Antwerp at Sea. The port authorities are there as well, and Fluxys is also there to foresee some local development, some local backbone in the port area. In Ghent, there we are also in a partnership with North Sea Port and ArcelorMittal. We are studying a CO2 liquefaction terminal. That's also the case for Antwerp at Sea. There we are developing the local cluster, but we are also part of the development of the CO2 liquefaction terminal together with Air Liquide. In Ghent, we are studying that together with ArcelorMittal and North Sea Port assets. And then just before summer, we also announced an offshore project where CO2 can be transported directly from the Zeebrugge area up to Norway. So that's an exercise that we do together with Equinor, a well-known Norwegian company. And by those 3 projects, and that's also the reason why I highlighted them over here, we provide to industry solutions. We say if you do carbon capture at your plant, Fluxys will transport it to one of those 3 exit points, and then you can get connected to the sinks. And by developing this infrastructure, this is a proposal, but by developing this infrastructure with the focus on those clusters, we also provide the opportunity to get a new economical development, the development of the usage of CCU, of CO2 in that perspective for e-fuels or something else. So that's a bit the overview on what we are doing at Fluxys at this moment in time. Thank you.
Are there any questions for Steven? Yes?
Hello, Emer Greyman from Southpole. I just had a question on the timeline for that Belgium pipeline network that you're looking at. So you mentioned trying to have more firm commitments mid next year. But then between that and having it online, what do you expect as a timeline?
A good question. It's mostly a question on the timeline or one of the price. So that are the main topics in the Q&A session. I'm going to answer for the two products. For hydrogen, there the timeline is also to have some binding commitments around summer next year. Have the FID close to that date to be operational in 26. So that's the ambition over there. Not a whole network, but the developments in some clusters where industry raises hand and says we want to have hydrogen available at that moment in time. So that's for hydrogen. For CO2, it's a split answer. I think the consortium in Antwerp at Sea, they started earlier than the rest. So there the timeline is to be operational in the area around 25. So normally FID will be taken next year as well. And the other developments mostly orient to some years later, 27, 28, 29. We see an enormous momentum in the industry. I was talking about 40 MTPA. In the request for information, we received projects that industry is looking at for 20 to 25 MTPA in the time frame 2030, 2035. So the year to be operational over there is late 20s to be ready.
Somebody wants to ask a question about the budget? Okay, I see a hand over there and one over there. Mark, you can use your microphone. Just press the button.
Yes, I would like to ask. You are developing an infrastructure for CO2 transport. What kind of proportion do you see in the future in between reusing rather than storing CO2, which is also altering the way you will develop your infrastructure?
I think in the first stage it will be mainly, and mainly I say 90% plus. It will be storage, but I think you cannot have a usage economy before you have CO2 available. So having some carbon capture developments with storage in the first phase is an enabler to the development of the usage that can come close afterwards. So I don't know what future will bring, but when we say we will have some infrastructure available in all those industrial clusters in the country, then I think we provide the CO2 to the industry to develop the usage as well. So it will, that's a personal opinion. It's not a company statement. But my personal opinion is that it will come in a second wave, the usage.
Okay, there were 3 more questions. I'm going to ask to introduce yourself before you tell your question. And let's also first ask the questions and then you can answer them all at once.
Yeah, okay.
Yes, there was a question over there somewhere. No? Okay, 1, 2, and 3. Yes, go ahead.
Okay, Sebastian Lubers, Prognos. Yeah, there's one question regarding the carbon network. Is it the idea to build a completely new network or to use the old gas infrastructure?
Erwin?
Erwin Cornelis, ECOS. Perhaps the question is related, I couldn't hear it well. So it also had to do with the transition of the existing gas network to hydrogen and CO2. And does it mean then that parts of Belgium will be cut off natural gas because that pipe will be used for hydrogen or CO2?
And then the last question.
Hi, Sophia Schönborn, Industrial Trade Union IGBTE from Germany. And my question is, how is the situation now with Russia and the energy crisis affecting your project? Is it more pushing it, or will it be thrown back in time? Thank you.
Yeah. Okay, I think those the questions of the gentleman are rather similar on the availability of the infrastructure and the repurposing approach. Let's say that the first development there will be a huge part of new constructions, but into the clusters there are from time to time some opportunities to make available some pipelines. I give one example in the area of the port of Antwerp. Today we have a high-cal and a low-cal network. We are converting it to provide a high-cal gas to everybody over there. That means that the pipeline of the low-cal gas becomes available. So that's a part of a pipeline that we can use or for hydrogen or for CO2. We are not talking about hundreds of kilometers at this moment in time, because we do not have a spare network, and that would not be very cost efficient on the gas network. But if the vision of everybody is that somewhere around 2050 there will be a huge decline in natural gas consumption, some parts of the network will become available. And that's also the reason why Fluxys decided today already that every new investment in the existing infrastructure will be performed hydrogen ready, CO2 ready, making it more easily to switch to one of the new molecules in the future. And then it will be a stepwise approach, and this figure is showing that we will not cut off some areas from the natural gas today. We will rather provide a second and a third network so that industry can make up their minds, can make the decision at their investment cycles to switch from one product to another. And then the last question on the energy crisis as we know it today. I think the infeed of natural gas is cut off in the east, and it's compensated by flows mainly brought to Europe by LNG carriers. Zeebrugge is a huge entry hub for LNG, but also for pipeline gas coming from the UK, coming from Norway. So we are transporting at this moment in time huge volumes to Germany. So it's not a throwback on this plan, but it can have an influence on the speed of repurposing. So that's a trade-off that must be made. But just to give you an example, the import capacity that we have available today and that we are using now at almost 100% in Zeebrugge is 80 gigawatt. 80 gigawatt. We are talking about the nuclear fade-out in Belgium. Then we are talking about 5 to 10 gigawatt. So 80 gigawatt is the import capacity of energy in Zeebrugge.
Okay, thank you very much, Steven. Then now it's time for our first coffee break. There will be coffee and sweets, so go ahead, and we start again at 11:15 sharp. In this session, we have people from cabinets and administrations from the 3 countries we are considering. So the first speaker is Tom Mikunda. He's a senior policy advisor at the Dutch Ministry of Economic Affairs and Climate Policy. Tom will join us via Zoom. The next speaker is Maxime Sallier. He's a policy advisor at the Belgian Federal Ministry of Energy, so the Ministry of Tine van der Straten. Tommy Kunda is from the Ministry of Mickey Adriaanse. And then we have Dr. Michael Walter. He's the team leader at NRW Point Energy for Climate Initiative, and he's the team leader of the industry department. And he will also tell us how the industrial policy is regulated in North Rhine-Westphalia. So let's start with Tommy Kunda. Tommy Kunda will join us via Zoom. Hello, Tom.
Hi. Hi.
People are still entering the room after the break, but you can already start. We are ready for you.
Okay, great. Yeah, perfect. Well, thank you. Sorry I couldn't be there in person today due to personal circumstances, and also at short notice I couldn't find a replacement to represent the ministry. But I'm happy to share with you some insights into industrial climate policy in the Netherlands. I'll apologize in advance. Some of the diagrams and pictures have not been designed for an international audience, so some things are still in Dutch, so you can consider this a free Dutch language course as well. And also in the Netherlands, we like to use a lot of abbreviations, which when translated to English make no sense whatsoever, but I'll try and share some of the principles and key policies behind the industrial climate policy in the Netherlands. So without further delay, yeah, so just a bit of a background before we start on the current picture in the emissions, the CO2 emissions from industry in the Netherlands. For a relatively small country, the Netherlands has quite a strong industrial base due to both the logistical advantages, access to the North Sea and the river system, and also historical access to national natural gas production, which has got quite a strong petrochemical industry. From the map of the Netherlands, a number of the majority of the emissions are clustered around a number of key areas. So the north, around the Amsterdam area, also of course Rotterdam, the industrial part in the Rotterdam area, also bordering the Belgian border in the Zeeland cluster, and also towards the German border with Belgium and Germany, so the Kemmelot area around Sittard-Geleen. We don't need to really. What we see is a lot of a number of large companies are responsible for a relatively large percentage of the total industrial emissions, and these companies are also so obviously very important in dialogue with the ministry, and many of the policies designed take into account also the possibilities of decarbonising these large companies and these large emission installations. So just to talk a little bit about targets. So in 2020, we closed the Dutch Climate Agreement, which allocated a large CO2 reduction for Dutch industry for 14.3 megatons to be reduced by 2030. With the Fit 55 package, additional CO2 emission reductions have to been identified from the different sectors of the Dutch society, and then in this case, given the relatively large emissions and the potential emission reductions that could be achieved in industry, additional 5.9 megatons of industrial emissions have to be reached by 2030. In order to achieve this, in the Dutch coalition agreement of December last year, 22 billion euros in a climate fund set aside to be allocated for emission reduction in industry. I should also point out that as well as emission reductions, of course, what is also a priority is maintaining and improving competitiveness and the investment climate for Dutch industry, and also the prevention of carbon leakage is also very important. So how do we get there? And I'll focus on a few more of the specific policies as we go along this presentation. Combination of regulation, emission pricing standards, combined with policies to assist industries in making the step over to sustainable and carbon reduction achievements through the expansion and addition of new subsidy instruments. Another important area, which is a relatively new area, which is currently in development, is what we call a tailored agreement with the large industrial clusters, as I mentioned, of the sort of the 12 main industrial emitters there. This current policy is being, as we speak, is being worked out at the moment. It's being taken shape throughout 2023. First step is the inventorization of what's possible within these different companies, and then have an agreement framework which sets out sort of the boundary conditions and the constraints upon which potential financial support can be given. Once that's agreed, to sign letters of intent between the government and the companies, and then eventually these should become binding agreements to make sure that the emissions happen. These particular kind of tailored agreements, and in Dutch, we call that maatwerk, then 7 billion is reserved for these agreements. So just to take a step back and look at what is actually behind decision making, and what is actually gone into the climate agreement. There's a number of during the climate agreement, the formation of the climate agreement, there was a lot of independent research done to look at the whole industry from a top-down approach, and look at the different emission reduction possibilities throughout industry, and what the expected cost reductions will be in order to start shaping policy instruments designed for the specific technologies that could have considerable impact. As I mentioned, this is all in Dutch, but you can see that the blue areas, for example, there's a lot of reduction seen for CCS and blue hydrogen. At the lower cost end is of course reduction of energy demand and sustainable, looking for more sustainable sources of industry of energy, for example. And at the higher end, with a higher cost, circular use of resources and products, but as well as the top-down approach, which is all well and good, but obviously different companies have different. Oh, sorry, I'm going a bit ahead of myself. But basically, what this turned out is that this resulted in a sort of an overview of where the main emission savings could be met. So the main key areas: process efficiency, energy saving, electrification and green hydrogen, and CCS sort of being the main pillars upon which the policy towards 2030 would be developed. And and also in order to reach that 20 megaton saving that we need to reach the 2030 goals beyond. So as well as the top-down approach, what was initiated straight after the agreement after the climate agreement, were a number of cluster energy strategy studies that of those those 5 main clusters, plus an additional one, we called it the 6th cluster, which covers a lot of emitters that aren't necessarily located within those, within the sort of the 5 main clusters. These regional evaluations were actually carried out to get a greater insight into the potential strategies for decarbonisation, calculating the emission reduction possibilities, and of course the very important infrastructure requirements in terms of, for example, improving the electricity network, hydrogen pipelines, heat and steam pipelines, CO2 pipelines, looking at any additional energy requirements, sustainable energy requirements, and of course investment needs. And these would be sort of the main, the background to which future decisions would be made in each of these clusters, and how government support could will be tailored to these different clusters. I will say that, of course, industry has specific needs. It's a very complex system with very different sectors and different sector needs. And in this case, as you can see, the policy framework for industry is also quite, well, it looks complex, but let's just say it's wide ranging, and it has to be developed for the different needs of industry. But maybe just to focus on a couple of areas, of course, sort of the market pull, if you'd like, or the often called in economic policy language the stick. So it's a mixture of the stick, the carrot and the stick, if you like, with in the regulation and pricing of emissions. There will be a national CO2 levy that goes on top of the ETS to make sure that there's which will eventually be 135 euros by 2030. Obviously, the impact on companies is dependent on the price of the ETS. So this is something that goes on top of the ETS to maintain a consistent incentive for companies to take this. Setting of standards, for example, that where an energy efficiency measure has a rate of return of less than 5 years, that companies are obliged to make that investment. So that's sort of the market pull side. And on the other side, to actually realization, industry has to maintain competitive with neighbors, neighboring countries, and Europe internationally, also to ensure that the right incentive or the right support mechanisms are in place. For example, we have a number of policies, that SDE++ perhaps being the most well known at the moment, but there's also another of other policies that are in development or available at the moment, are being expanded and looked at throughout 2023. And I'll say a bit more of that. And of course, there are also a lot of innovation mission programs which are looking to support technologies and development and bring them to higher TRL levels. So this perhaps sums up quite well what I just said. So the Dutch climate policy for industry recognizes the needs for different size of companies, and it's also combines regulative instruments with support schemes. And at the same time, the subsidy is designed, if we look at this orange box here, there are subsidies in place to take technologies from fundamental research into development through to demonstration and then scale up and market integration or market introduction. So it's a myriad of policies. These policies, there is a rhyme and reason to these policies, and it's because there's so many needs of the industry in the different sectors that we have to have a number of quite a wide range of policy instruments. Maybe just to touch on the SDE++, which I will talk about this somewhat in my CCS presentation later. So it was an existing policy that was broadened in 2020 to include industrial CO2 reduction techniques. It's not just CCS, there is also the reuse of residual heat, industrial heat pumps, integration of sustainable energy, electrical boilers. But as we see at the moment, the CO2 storage, CCS for the majority of industries, can facilitate the highest emission reductions for the lowest price. And that's what we've seen from sort of the first 2 rounds of the SDE opening since 2020. That's been a lot of attention towards CCS. I just mentioned these additional policies, so it's not just the SDE++. There is the scheme for accelerated climate investments in industry, which is focused on process efficiency and energy saving. And also for the demonstration of energy and climate innovation, the DI+, which is focused more on demonstration plants and scaling up of pilot plants into demonstration plants. Also, since this year, currently being worked out is National Investment Scheme for Climate Projects in Industry, the NICI. This is a new scheme for large scale industrial projects that don't necessarily fit into the SDE++ at the moment, such as green chemistry and electric cracking. And these, all of these policies are linked to that initial 22 billion euros worth of financing that's been set aside in the coalition agreement. And of course, not to forget, scaling up green hydrogen has its own bespoke financing mechanism. And of course, industry infrastructure is also really important, specifically in these industrial clusters. And for industry, there is also separate policies put in place, leading on from the energy cluster strategies that I mentioned. So the sort of the 6 energy cluster strategies. There is a specific team that's been set up within both the Ministry of Economic Affairs and the Ministry of Finance. It's called the Infrastructure Program, or Sustainable Industry Infrastructure Program. And the goal of PD, as it's called, is to accelerate the identification and implementation of MEEC projects. You do remember I warned you of the abbreviations earlier on. So the Multi-Annual Energy and Climate Infrastructure Program are the specific projects, if you could say, yeah, national projects of importance. And these are, for example, some of the examples are grid reinforcement in the Zeeland region for electricity, hydrogen backbone, the Delta Corridor, Rotterdam, Chemelot, and Germany, and the CCS backbone in the North Sea. So these are projects of national importance that will be prioritized and will be supported by the government. I think I may have used up my time and just come out well, so I look forward to the panel discussion later. Thank you.
Thank you, Tom. After the panel discussion, there will be room for questions also to Tom, so hold your questions until then.
Good morning, everybody. Is the microphone working? No. Not yet? It is? Ah, perfect. Good morning, everybody. I'm really glad to be here today to discuss with you our plans to decarbonize the industry. In the 19th century, fossil fuels opened a brand new era for us all, with a lot of new opportunities and possibilities that allowed us to accelerate our production processes and supply chains, also to increase our material comfort, without having to worry too much, at least at first, about our energy and the source, the origin of our energy, as well as its impact on the environment. Today, climate change is accelerating, and it urges us to take the necessary measures to preserve our planet. that's really the key point here. In order to reduce our greenhouse gases emissions by 55% by 2030, and also to become the first climate neutral continent by 2050, our energy system needs to transition from fossil fuels to renewable energy. Our goal is to build a sustainable world in which we benefit from the resources that the Earth provides us, without overexploiting them, of course, also in which our activities don't cause global warming, and in which access to energy is democratized and no longer used as a geopolitical weapon. Much of the energy transition will focus on electrification. And I think it's rather important to point this out because we are a lot talking about hydrogen, about other types of solutions, about CCS also. But electrification, according to me, is really key in this story. But simply because electrification is the most effective way for us to consume renewable energy and to access the resources that the Earth provides us. But electrification will not be enough for two main reasons. The first one is the way we consume energy. Electrification is not always technically feasible or economically viable for some applications, including many industrial processes which require high temperature, which sometimes also require fuel, but also other applications that use the same compounds, also some kind of fuels, as raw materials in their chemical processes. The second reason why electrification will not be enough here in a full renewable transition and energy transition of our society is our dependence on imports. Belgium is committed to maximize its renewable energy production, definitely. But despite electrification and energy efficiency measures that will be taken, our energy demand exceeds our renewable energy production potential. And these other vectors, then electrons will be needed, and we definitely also need to find other solutions for these demands. These two observations are deeply true for Belgium, but I think they are also true for Germany and the Netherlands, and I think this is also the main interest of today's conference and of being able to gather us all today here. The good news is that, part of the solutions, or at least one of the solutions and technologies to tackle these two issues exist and are called hydrogen and renewable molecules. Sorry, I forgot to pass the slide. Let's go directly to the second. The reason for focus on renewable hydrogen and molecules is rather obvious from my short introduction, but is also a question of democracy. The thing is that where fossil fuels are concentrated in the hands of a few countries, renewable energies can be produced from most locations on Earth. And this characteristic is certainly not to be underestimated, in particular in the current context of the energy crisis. Our ambition is to reach 100% renewable energy system, but also society, as soon as possible, and in any case, before 2050. However, the word transition in the term energy transition is certainly not chosen at random. The implementation of a 100% renewable system takes time, requires time and everyone's efforts. And intermediate steps will definitely be necessary, including how to adapt the way we produce hydrogen and renewable molecules. We do see also a role for most of the existing technologies in this, but policymakers as well as industry and all actors will need to ensure that these transitional measures do not lead to fossil lock-in. The Belgian federal government is fully aware of these issues for the industry and the applications that could hardly be electrified. And it has therefore adopted a hydrogen vision and strategy last year, back in October. This strategy is composed of 4 pillars, which are depicted here on the slide, and I propose that we briefly review them together. The first pillar consists of making Belgium an import and transit hub for renewable molecules in Europe. As a small country, Belgium has always been an importer of energy and materials. We don't have mountains, we don't have hydropower or oil and gas in our subsurface. And our strategic location is, our strategic advantage is definitely our location. In the heart of Europe, of course, but also at energy infrastructure crossroads, which makes it really useful to connect people together. To meet our domestic demand, we estimate that Belgium will have to import significant quantities of renewable hydrogen molecules of up to 3 to 6 TWh by 2030 in the first phase, but then by 2050 up to 100 and 165 TWh. Belgium has also the ambition, as I just mentioned, to become an import and transit hub for renewable molecules. And well, given our strategic location and great port infrastructure, we can become the door to Western Europe for these molecules. We are already playing this role today for natural gas, and this role has even more been highlighted here by the recent crisis with the war in Ukraine. By simply helping our European partners to access large volumes and quantities of LNG from the West. We want to do the same in a very near future, but also then for hydrogen and renewable molecules. It is we estimate that this transit activity could double our import volume. So I mentioned 100 to 165 TWh by 2050. We think that twice this amount could be required also to feed our neighboring regions. The reinforcements of our interconnections will create economic benefits for all, and that's also very important because it will increase our bargaining power with respect to international producers of renewable energies, but it will also help to create unique or united markets for these molecules, which then also steer competition. Several measures are being put in place to see this ambition realized. First of all, we can mention our support to the development of hydrogen import infrastructure in any form whatsoever, provided that it allows the import of renewable hydrogen from distant countries and distant locations with the aim of injecting this hydrogen on a pipeline network, on a transport pipeline network. We're also working on the implementation of a voluntary European certification scheme to ensure the certification and traceability of these molecules, and that's also key in a context where we are using hydrogen for the decarbonisation of our industry, because if the hydrogen is not renewable, it would make no sense to use it to reduce our CO2 emissions. Also, development of a robust hydrogen market is key here, and it will be the subject of Pillar 3, so we come back to that a bit later. And finally, the international cooperation will be the subject of Pillar 4. Now, the second pillar, that one is focused on confirming our role as a leader in the hydrogen technologies. Many Belgian companies and research institutes are already active in the hydrogen value chain, from development of production and consumption technologies to the integration of these technologies into more complex solutions. We want to maintain and strengthen this leading role of enterprises and research institutions present here. And we have therefore adjusted the available instruments to support them in this way. We've also created new ones, and to be mentioned, maybe our Energy Transition Fund, which was created a few years ago, but which was also remastered in order to best support hydrogen technologies. Also our Clean Hydrogen for Clean Industry call for projects, which was launched in April this year, and also our import call, which will be launched by the end of this year. And then finally, the federal government is also investing 16 million euros in a hydrogen test facility, which is a kind of research center for hydrogen innovation, to allow companies and universities to gather, test, and develop new technologies with hydrogen and renewable molecules, of course. The third pillar of our strategy is aimed at establishing a robust market here in Belgium. Fair competition and market liquidity are really key to favor innovation and to supply industries at the least cost. And this is really the reason why we are also focusing not only on import, but also at establishing a strong ecosystem in our country. 3 levers are activated in this regard. The first one, we organize the efficient, we are currently organizing the efficient planning of electricity, natural gas, but also hydrogen and CO2 infrastructure, in order to make best use of the existing infrastructure, existing pipelines and other kinds of infrastructure, to minimize the development cost of the networks that we will need through the energy transition. Talking about infrastructure, we also need to further develop our hydrogen networks in order to best connect supply, demand, but also import locations. In Belgium, we have one of the most extensive and well-connected hydrogen networks in the world, and that was already mentioned by some speakers earlier this morning. The federal government has the ambition to further develop and to support the further development of this infrastructure, and it has therefore foreseen 95 million euros to further extend this infrastructure in the first step, and in an approach of cluster development, and then an additional 300 million euros to accelerate the interconnection of these networks with all our neighboring countries, while knowing that already today we are interconnected with France and the Netherlands. Which means the next interconnection should be most probably with Germany as soon as possible, and hopefully before 2028. Developing a transport infrastructure is nevertheless not sufficient to steer competition and support the fast and efficient development of the market. We also need a kind of regulation that ensures that all interested parties and market actors get access to the infrastructure under non-discriminatory and third-party access. This leads us to the third lever, which we use to build this third pillar. And this third lever consists in establishing a regulation to ensure this third-party access to the hydrogen networks, but also to guarantee the unbundling of the network operator. The European Union is currently working on its renewable and decarbonized gas package, and this is really an initiative that the federal government strongly supports. But the revised directive and its transposition in national law will take time, and a bit too much time, according to us. The advanced state of development of our hydrogen markets, as well as the presence already today of an extended hydrogen network on our territory, urge us to take our own initiative in this regard, and thus faster and ahead of the European regulation to come. The process of setting these principles, third-party access and third-party access to the network infrastructure and unbundling of the network operator, are already being set up and integrated in law, and this process should be finalized by Q1 of next year, hopefully.
1 more minute.
That's great, because it's my last slide. The last pillar of our strategy, but certainly not least, is cooperation. Reaching our climate goals is challenging, but so is also the development of hydrogen and renewable molecules ecosystem. This requires the construction of new infrastructure, the opening of new import value chains, and the adoption of new market rules. The implementation of these measures can only be done in collaboration with all stakeholders. Cooperation is needed at all levels, with companies, with universities, but also with our European partners, with our international partners, also with local governments and citizens. The scope of the work is very huge, and I believe that we can leave no one, we cannot leave anyone out of this story, because simply otherwise we won't be able to reach this target. Cooperation was initiated early on by my minister, Tine van der Straten, since the beginning of her mandate, among others by engaging with women in Namibia. These initiatives, we are pursuing these ones on a daily basis to see our vision become reality and enable the decarbonization of all sectors, including, of course, the industry. So you can easily understand my excitement to be here today and to discuss all these topics together. Thank you.
Is this on? Yeah. Okay. Hi, everybody. I'm thankful for the opportunity to give some insights on what we're planning right now in North Rhine-Westphalia when it comes to industry transition. We're just a few presentations in today, and it's already clear that we have a lot in common in this industry cluster: Belgium, the Netherlands, and North Rhine-Westphalia. So, I try to pick the more interesting parts for you from this presentation, and not repeat what we've heard a few times before. This is the...
Yes.
No, this that North Rhine-Westphalia is this huge industry state in Germany, as well as we have this industry cluster here. I'm just using this slide to pick one point that leads to what we think is the main task for politics right now. That is the bottom on the right, that there's a huge reinvestment wave is coming in industry. There's a lot of companies already delaying reinvestments for a few years now because of uncertainties on which technology path to choose, and there's a lot coming in the next years. And as politics, we think the main task right now is to steer these investments in the right direction. That is the climate neutral technologies, and for that we need to create the right environment for industry companies to make these investment decisions, and that is make sure that there's renewable energy and green hydrogen in the system. That it means we have to make sure that there's the infrastructure in place for hydrogen, for CO2. We already heard that today, and that is to work on bridging that gap between ready or nearly ready technologies to be put into practice in industry, and the largely or completely missing business models for industry. This environment for industry has to be created for industry to then invest in the future technologies, because we believe that it makes less and less sense for industry to invest in the old technologies within the European Union. So if our plan is to become climate neutral by 45 in Germany, that is, not by driving our industry away, but together with our industry, we need to create this, this environment for industry to invest. Now, this I can almost skip completely. Just as a reminder that as North Rhine-Westphalia, we're not working under a framework given by the European Union, an important framework we subscribe to, but we also operate under a national framework, which further limits our scope of actions we have as a state. On the other hand, there's some highly important policies on the national level that we heavily pushed for as North Rhine-Westphalia. For example, I highlighted that here we will start a program with carbon contracts for difference for steel industry and parts of chemical industry. And that is because, as I mentioned, we need to bridge that gap between the technologies that are nearly there and the missing business models for companies. On both levels, we have very important programs for innovation funding, and our national government right now is working, just started working on developing a carbon management strategy, which we as North Rhine-Westphalia published a year ago as first state to do so. Now, to very shortly clear up what all this NRW, Energy for Climate and InfoClimate North Rhine-Westphalia is, we institutionalized most of the climate protection policies and goals in North Rhine-Westphalia. At the beginning of this year, in a new agency called North Rhine-Westphalia Energy for Climate, where I'm representing the industry unit. You see second from the left, and you also see that the platform we've been working the last 4 years on InfoClimate North Rhine-Westphalia is still there, and it's still ongoing as the platform to really work on industry transition. As Jonas said, we've been sleeping on that topic for a long time, and we try to make up for that in the last 4 years by bringing together under this initiative InfoClimate North Rhine-Westphalia energy-intensive basic materials industries and the state government and our own research project with some high-profile research institutes we have. And our main InfoClimate office, of course, to really work together on the industry transition topics with no surprises there, working groups on hydrogen and on the carbon, on carbon management and circular economy and process heat and so on. What we did is publish a lot of research as well as position papers aimed towards industry as well as politics. Right now we're in the position to address additional topics as the industry unit of this larger agency. What we'll be doing in the future is to look more along the supply chain downstream to work more closely with a lot of companies in the processing and manufacturing industries. Deal a lot more with SMEs. And try to bring these all under one roof when it comes to develop a roadmap and a way for North Rhine-Westphalia to transition within a larger national and European framework. We also aim to work more closely together with the industrial engineering companies, that part of industry we need as a solutions provider for all other countries, companies to transition their production processes. we have a small project on resources, on which resources are necessary, and on ways to secure these resources for Germany as well as Europe. And we have our own project in the Rhenish region, a lignite mining area in the south of North Rhine-Westphalia, where there's a huge structural change going on right now, and we're trying to combine industry transition with helping them in this structural change there. These are some of the results of the last years, real results of a collaborative effort between InfoClimate and the state government and industries. The hydrogen roadmap we published 2 years ago, the carbon management strategy is about 1 year old, and they're kind of child, the action plan for synthetic fuels. And now we'll have to develop these further and put these into practice. And this is where I skip to our next steps and what's in the coalition agreement. That's for a quite new government in North Rhine-Westphalia. And that is for hydrogen, of course, to further promote the hydrogen use in industry wherever that's sensible, not just everywhere. We have the IPSA projects starting. ThyssenKrupp just started their hydrogen IPSA project. We have to work on, and that is where this region comes into play. We have to work on the hydrogen infrastructure. We have to ensure this pipeline network to further develop, to just exist. And what's especially mentioned in the coalition agreement is liquid hydrogen transport. Same goes for the carbon management strategy. Also, this needs to be further developed and put into practice. We have a pilot project on climate neutral cement. We're pushing for or supporting the development of a CO2 pipeline infrastructure. And some additional points from a coalition agreement. Of course, especially under the situation we're having right now, there's even more push for an acceleration of renewable energy expansion and also green hydrogen production in North Rhine-Westphalia. We will keep on funding as much as we can as a state with not that much financial potential funding of projects. Often these are feasibility studies to then move on to national or European funding, but also to directly support innovative projects. Further strengthen R&D for climate neutral production. And there's a mention in the coalition agreement that there should be or needs to be a climate check for our funding programs. I don't know yet how that will look or work out. What we're heavily working on right now is the next point, the Industriepakt, Industrial Pact, where it's a clear goal of the new government to involve more industries than we did in the last year, with that focus on the energy intensive basic materials industries. We're talking a lot of medium-sized companies also needing to transition their production processes, mainly when it comes to process heat. Process heat is 60% of industrial energy consumption, and it's not just the big companies, it's the width of the whole industry landscape. And right now we're developing a concept on how to engage these in workshop settings for different industry sectors, for maybe different temperature levels. This is what hopefully will start this year. I think it's only the last points that I have. These are not so much starting this year, but hopefully early next year there will be this master plan or strategy for geothermal energy. We will write a circular economy strategy for North Rhine-Westphalia. Very interesting how that turns out, because I feel it's so broad. And if I have just a short time, the last point is what I'm working heavily on is societal acceptance of industry and technologies, which is often overlooked, but which can easily delay the industry transition by a few years, especially when local protests arise, wherever we're trying to build hydrogen or CO2 infrastructure. And we have to keep that in mind, and we have to actively be a part of the societal discourse and to communicate, or we may run into these protests and see a whole timeline we had planned for industry transition collapse. Okay. Ask me anything. If I'm busy, my colleague Stefan is also here, and you can ask him anything, and we have a lot of coffee breaks. Thank you.
Thank you so much, Tom and Michael and Maxime. Maxime, you can also take a seat in front. We're going to see if Tom is still with us. Hello, Tom. We're going to start the panel discussion. So, Maxime, I first have a question for you. To mention the elephant in the room, we have heard the Flemish level, we have heard the federal level. Why is Wallonia not present? We reached out to Minister Boursu, we reached out to Minister Henry. Is industrial decarbonisation not a priority for them?
Difficult question to answer, of course, because I'm not working for the Walloon government. Now, I definitely think that decarbonization is also on their agenda. At least that's the message I also receive. They also have the ambition to reach climate neutrality, definitely, also to push renewables and to find other solutions. But I think this question should rather be asked at them.
Let's have a telephone call after this conference. So I also need to congratulate Belgium, because it's one of the only countries that actually submitted plans for CO2 and hydrogen infrastructure in their resilience and recovery plan. So Belgium got funding for this from the European Union. How is it going? Because we saw that hydrogen has already a lot of plans. Are there also similar plans to coordinate the CO2 infrastructure together with the regions, of course, because CO2 is also a regional authority?
Yeah, very correct, indeed. So within the recovery and resilience plan of Belgium, we also introduced some projects for the further development of the hydrogen networks, but also for development of CO2 transport network. This is also linked with to the intervention of Steven van Kagenberg earlier this morning. CO2 infrastructure is also definitely important. That is sure, and we also support this, and we also see a really strong role for CO2 infrastructure in Belgium. But as you also mentioned it, CO2 transport is not an exclusive federal competence. That's a bit of complexity, the institutional complexity in which we live in Belgium. But this is no reason to not develop it. So we are indeed also working with regional governments in order to see how we can cooperate and collaborate for this development. Regions have a role to play on their own territory. Federal government has also a role to play for the export of the CO2 via the sea. For instance,
and who is coordinating these efforts?
Well, it is rather a collaboration, simply because there is no hierarchical level between the governments. Each government has its own competencies. So that's the current state of play.
Okay, thank you. Tom, have you ever seen Michael or Maxime before? Can you hear me, Tom?
Yeah. No, I don't believe I have met them, no.
Okay, then this is a very good opportunity to start working together and getting to know each other. Are there already regular meetings in between the Dutch and German and Belgian governments or administrations?
Yeah, certainly. Yeah, there are. Well, particularly with regards to CO2, and also with regards to the hydrogen backbone. There are a number of discussions ongoing. Yes.
Can you tell us a bit more about that? What is discussed? How is the dynamic going?
Well, I think it's really a combination of understanding national policy and what the national policies are and what are the requirements, and it's also about, as well as matching the needs of the industrial stakeholders, it's also important to understand the national policy mechanisms are in place that can support the development of these large industrial infrastructures. And as you can imagine, the sort of investment needed to get these infrastructure off the ground and installed requires a very high level of commitment between the governments. And yeah, there are discussions ongoing for sure, but I'm not aware of major agreements being put into place at this moment in time, just because of the size of these investments necessary. Really.
Michael wants to say something about it.
My particular area is on CO2 transport, and I think that there are some discussions, because there are certainly some discussions going on between the Netherlands and Belgium in that regard.
Michael?
Yeah, I kind of agree with Tom. We have a quite good exchange of ideas and views on the expert level when it comes to the ministries in all three countries. And then we have on the higher political levels, we have MOUs and declarations, and we need that next step to become more specific in what we're doing together, and really put these into programs to develop something together that goes beyond exchange and understanding each other and learning each other. And that's a step that's still missing from my perspective.
Do you agree, Maxime?
Yes, definitely. So there are quite a lot of contacts at different levels, also within institutional organizations such as Benelux, also the Pentalateral Energy Forum. There are a lot of contacts, I think, between our respective TSOs, which all have different ambitions with hydrogen and CO2. But I think that we should go a step further, as Michael mentioned, in order to make it become reality.
Okay. Tom, do you think there is a role for industry or NGOs to help, or the unions to help make these plans more concrete? Because we have an audience of NGOs, industry and unions today, so I'm sure the room is also interested in the role they can play.
Yeah, well, definitely. I mean, industries, in my opinion, industry is leading in this respect. They understand the needs and the business cases of these infrastructures better better than anyone because it's their business. That's what they need for their business. So in this regard, industry is leading, and industry does approach the ministry to share their ideas and needs and what needs to happen. From an NGO perspective, I think this is a very good example of bringing heads together to share knowledge and share policies in this regard. So, and I think particularly in the Netherlands, NGOs are very supportive with regards to the decarbonisation of industry, and particularly the link between sort of the provincial governments and the national governments. Their NGOs, particular NGOs, play a really important role.
Thank you. Michael, we heard from Thomas Wijns that the national level plays an important role in coordinating the roadmaps towards zero carbon industry. Is the government in Germany playing its role, according to you?
The national government definitely has its hydrogen plans in place, and it's playing its role when it comes to renewable energies. And we're quite happy that we were the front runner when it comes to carbon management right now, and that we can influence the national carbon management strategy. But yeah, of course, they're setting, as I said, an important framework for what we can do as North Rhine-Westphalia, and of course what we cannot do. But I don't see the national framework in Germany. It makes it easier in some cases to, for example, work with Northern Germany and not with the Netherlands, because we're operating under the same framework. But I don't see on the national level in Germany much that should hinder working more closely together in this industrial cluster.
Okay, high on topic of the agenda is of course the war in Ukraine and the rising of the gas prices as a result of it. This has a huge impact on families but also on industry. Maxime, how do we make sure that both industry and families survive the following years?
Yeah, that's a very good question. That's one of the greatest challenges we face today. The war in Ukraine has a tremendous impact on our finance, on our also relation with energy. Well, I think that maybe first of all, the war in Ukraine has showed us how deep and how much we are dependent on fossil fuels and on natural gas in particular, also on petroleum and petroleum products. And this has somehow created kind of momentum, at least within political sphere, to accelerate the energy transition and to go for renewable. At least in Belgium, we've seen that in the past month. The federal government has started to take much higher and stronger ambitions with this respect, and also to put money on the table to make it reality. But at the same time, well, this more on the side of politics and politicians. At the same time, well, everybody is struggling with the price of energy today. So industries, companies, also households and citizens, and we need to find solutions for that, or at least we need to invest all our efforts in reducing this impact for them. Well, the European Commission has announced some measures, and we are strongly contributing to that. For instance, the announcement to establish a price cap on natural gas markets. I think and I hope this will really help, at least to temper a little bit the behaviors in the market and to lower the pressure on the citizens and the companies. But that won't be enough. Because prices is one thing, but we will not be able to directly lower prices back to the level we knew well pre-COVID and during COVID pandemic. So we also need to take additional measures also to help them. because not everybody faces the same increase in costs and in energy costs, and we need to make it realistic and doable for everybody.
Tom, do you agree with that? What is the approach that the Netherlands are following right now to make sure that companies and families survive the next years in the framework of the rising gas prices?
Yeah, I mean, I think the Netherlands, earlier this year there was steps taken to reduce the taxation of energy, to reduce the overall cost of bills to citizens. And yeah, there are of course discussions ongoing in a European framework about the energy market that are really ongoing at the moment, and I can't say any much more about that because I'm not involved in these discussions. But yeah, it's obviously it's an extremely difficult situation. The Netherlands is trying to take a number of steps. That's reduce consumption throughout both within companies and normal consumers, and secondly is potentially trying to boost domestic production of natural gas to try and reduce the costs. So yeah, and the third most important pillar is boosting and accelerating renewable energy goals. So accelerating deployment of wind, offshore wind. So that's sort of the steps that the Dutch government are taking in this regard.
Any thoughts about this, Michael?
Yeah, I mostly agree that, I mean, in Germany, most relief measures are situated on the national level. That's where interventions into the energy system, prices on in the energy system, or every other measure that helps households and companies in the short term right now are situated. As North Rhine-Westphalia, we're also trying to move forward to push renewable energy expansion and technology/fuel switch in a lot of companies. But of course, these measures, we can support them as much as we can. They come with a risk because whenever you fast forward some technology developments and companies which wouldn't have occurred kind of naturally without the actual situation, they have to be managed very good, very conservatively, and that's a huge task for politics right now. But that's what we are aiming for.
Okay, thank you. Last question from my side. Can you all answer me with two measures? Like, how do you want to involve external stakeholders, NGOs, industries, unions? What would be your ideas to involve those in the decarbonisation of industry? I will start with you, Tom. Or maybe you're already doing that. Then it's also very encouraging to hear.
I was thinking. Yeah, I mean, it's a good question, and I think I can only suggest that the climate agreement in 2020 done in the Netherlands is a really good example. All those stakeholders that you mentioned were around the table, the majority of them. Not all NGOs signed the agreement, but they were all invited to participate. I think something like that's a very good example.
And for the future, how do we keep this involvement alive?
Yeah, I think it's a very important for the ministry where I work that we main transparency and main contact with the NGOs about the decisions that are made and how decisions are made and why decisions are made. For example, increasing the ambition of climate targets and how we adjust policies in order to achieve them. I think that's really important that we maintain open communication with NGOs in this regard.
Okay, 2 sentences, Maxime?
Well, I think that first of all, we've been trying to do that as much as we can since the beginning of the mandate of my minister.
And how?
Well, by sharing our initiatives and asking for feedback on that. This has been done extensively for the first federal hydrogen strategy last year. This is something we've been continuing to do for the last year. And then maybe for the future, how can we ensure that this stays in time? Well, unfortunately, I couldn't tell now because these measures will be announced in our review of our federal hydrogen strategy, which will be published mid-October. So stay tuned.
Something to look forward then. Michael, we conclude with you.
Yeah. Industry is naturally involved in our working platform, so they're very close, and no reason to. I mean, they cannot be further engaged. We have regular exchange with the trade unions, but of course, right now we have the same goals. Everything we're doing is to create a framework that industry companies decide to stay in North Rhine-Westphalia.
And the NGOs?
We're talking with the NGOs, we're engaging NGOs, but they're not part of our platform. There's other platforms in North Rhine-Westphalia where NGOs directly engage with industry. So there's a lot of discourse going, and of course in a larger North Rhine-Westphalia Energy for Climate Agency, there will be also additional platforms to engage NGOs. Yeah.
Okay, thank you so much. Now it's time for the room to ask questions. So I will take 3 questions at once. First, please introduce yourself with your function and name, then Joep, and then Mark.
Hello, Samuel Flukiger is my name. I'm with ThyssenKrupp Steel. We just made some major announcements last week releasing funds for investment in Germany's and probably Europe's biggest DRI plant for steel production, to decarbonize steel production, part of our production. I have 2 questions. One to Dr. Walter. I was very interested to hear about your plans also to look into the acceleration of the permitting procedures. That will be a big bottleneck, of course. I assume this is not just for the permitting of renewable energy, but also the permitting of industrial installations. So if you could maybe just say a few more words on this, that would be very interesting. And then to Mr. Mikunda, maybe on the SD++ scheme, which is based on this competitive CO2 price. My question, and you sort of hinted at this, is that there are limitations to this, especially when it comes, we've seen it with renewable struggling to get into to qualify for the subsidy because of its cost profile. So the question is a bit more broad in terms of how granular the support schemes need to be to account for the specificities of the different sectors and the technologies. Thank you.
Okay, thank you. Joep?
Thank you. My name is Joep Zwijer. I work for ABN, which is a state-owned company in the Netherlands, active in CO2 transport and storage. I have a question for the German perspective as well. I hope do you understand me correctly? I have a bit of an echo. But on the status and the timeline of CCS in North Rhine-Westphalia and the connection to the Netherlands, for example, to the offshore storages, can you tell a bit more about that? Thanks.
Then Mark?
Yes, I want to ask more specifically to all 3 speakers, but mostly to Tom, how you see the involvement of trade unions in the whole process. And I just want to mention one example in the Netherlands where an enterprise was not really, let's say, the real mover, but it was a trade union.
Sorry to interrupt, but the practical thing, if you're not speaking, please mute your micro, because otherwise we get an echo.
Yeah, there is an example in IJmuiden with Tata Steel where it was not the enterprise which was really in the forefront of change, but it was trade union FNV. So that's why I ask especially to Tom, but also to two others, how do you see the involvement of trade unions and social organizations in the transition?
Let's start with Michael. Can you answer the questions of the Mr. from ThyssenKrupp and also from Joep?
Yeah, highly important question on permission processes and the time it takes for permissions. We have that in view, and this is not the first state government to tackle this topic. We've been trying to accelerate permission processes for quite some time now. There's actually two ministries in North Rhine-Westphalia working on that. It's a Ministry for the Environment also has a working group on accelerating these permission processes. But this is so important because we're not even at that point where the new technologies arrive and get into these permission processes. And we see with some pilot projects already that permission authorities have huge problems in dealing with technologies where there's no experience whatsoever. And this also is a point where I think cross-border collaboration could be a good topic, because in Germany we're not even talking across state lines, the permission authorities, and we have to learn from each other how to deal with these new technologies where there's very little experiences, and permission authorities are highly conservative. And when they start to work on unknown technologies and start calculating every risk there could be, we won't have we won't make that timeline we have in mind. Yeah.
And then the other question
on the state of CCS, as that was, yeah. There's no real timeline. We're waiting for the national government to develop that carbon management strategy. There's a lot of things to be done on the national level, for example, to sign that amendment to the London Protocol, which allows cross-border transport of CO2, which we haven't so far. As North Rhine-Westphalia, we're pushing together with business associations, mostly the VDZ for cement, and a cement and chalk and glass industry for the first projects on carbon capture and the development of a transport infrastructure, mainly pipelines. This is where we're talking a lot internationally, but there's no really set timeline yet, except that we're pushing and hoping that the national government follows.
Tom, two questions for you as well, about the SD++ mechanism and also about the involvement of the trade unions.
Yeah, for sure. The first one, yeah, both good questions, by the way. The first question regarding CCS in the SDE++. Indeed, the SDE++ is a system that prioritizes technologies with the lowest subsidy intensity. And when we look at CCS, particularly the lower cost CCS applications like CCS with hydrogen production or ammonia production, you see that CCS scores comes out on top in terms of subsidy intensity per the euro per ton of CO2 avoided. And we've noticed that, and it's been there. We've seen sort of in the rounds in 2020 and 2021. And we don't know yet for 2022, but perhaps this will show a similar picture. What has already been agreed for the 2023 round is that instead of having all the technologies thrown in one category, if you like, where they all compete against one another, in order to ensure that CCS doesn't drown out all the other technologies from 2023, there will be a system of allocation, where the different technologies will be allocated a different maximum budget. And in this case, you will not have then CCS competing with, for example, electric boilers or something like that. So that's a measure that is currently being worked out. This autumn, we'll start to see how that will be implemented and what budgets will be allocated for different categories. So yeah, that's I'll talk a bit more about that later in my other presentation. I think regarding the second question, I'm not hugely familiar with that, but what it's regarding is a situation where Tata Steel in IJmuiden shifted from a climate strategy focused predominantly on CCS to one focused on the use of hydrogen for steel production. And we saw an opinion made by the trade union that the workforce had a preference for the hydrogen route. You know, and which is completely, you know, it's just I don't know the ins and outs, but this is, I think this is, you know, it's welcoming to see the workforce taking an interest in climate strategies, and if the workforce think that the longer term vision for you know, for the company is one focused on hydrogen, then of course that's something that the government will definitely take into consideration. And there are measures, there's 2 measures put in place. There are measures in place for retraining of staff. Again, I'm not entirely sure of the policies, but something that's also really important is prevention of carbon leakage, because along with production and CO2 emissions going over the border, that also means a loss of jobs and innovation. So this is something that's clearly looked at by the ministry. But I'm not deeply involved in this area, so I can't talk much more about it.
Okay, thank you, Tom. We have time for 3 more questions. Over there, and over there. Yes. Yes.
Hello, Alexandra de Skonen from Air Products, an industrial gases company who also does a lot of hydrogen. I had a couple of questions. First for Maxime. One, just you mentioned, you know, Belgium wanting to be, you know, an import center, or at least, you know, planning on infrastructures. Could you tell us a bit more about these types of infrastructures, and where, and what they would be linking to? And then you also mentioned, on the side of the actual European gas package, Belgium is also regulating their own hydrogen market. How is this going to work with the gas package? And maybe tell us a bit more, even just the name of the regulatory project, so we can look into it. And then I had a third question for your German counterparts here. Specifically, I saw on one of the slides you mentioned carbon contracts for difference. It's very difficult to get a lot of information on how these would work and how you'll implement these. If you could tell us a little more too about these. Thank you very much.
There was another question there.
Yes, hello. My name is George Rodehuis. I'm working for TenneT TSO, the electricity TSO in the Netherlands, a large part of Germany. I had a question for Tom. That concerns the maatwerkafspraken, or the tailored agreements you mentioned. I can imagine that that is an agreement between government and the industrial party. However, that the outcome may be that there is also additional infrastructure needed to realize the agreement. Is there a process that you already foresee when you can involve the TSO or the grid operators in that area to secure that the needed infrastructure is also on time in place? Thank you.
Thank you. Last question was somewhere over there.
Yes, I'm Els Reinhardt from Studiedienst of Groen, and I have a question for Tom and Walter. Circular economy has been mentioned a couple of times. It's one of the main keys also for this transition. But I was wondering, when in the industry, it's mainly talked about then recycling plastics, recycling CO2. But what is far more difficult, I think, but very important, is also the whole circular economy in the value chain. So from the inner circle, let's say, of circular economy about longer products that are made to live longer, etc. And I was wondering, because this is much more, as it is a whole thing of the whole value chain, it's much more difficult in a way than just changing processes, which needs a lot of money and infrastructure and renewable energy. But changing this processes in the whole value chain is, does this get enough attention? I saw in Germany, the Industry Pact, there was a little phrase from also SMEs that should be involved, and that will be starting up now. So I was wondering, is it to avoid that all the money goes now in just the technologies, but also in the whole re-managing the process chain?
Okay, thank you. So let's start with Maxime and your question from Air Products.
Yes. So on the type of infrastructure that we foresee, well, honestly, we haven't made a choice, simply because we believe that the market has still to make a choice, and that the most efficient solution should be chosen, but will be chosen mostly by market actors. So in order to import renewable molecules and hydrogen, the main solutions we see today, but we are open for any other solution, are first of all pipeline import. If we talk about import from not that remote locations, somehow close to our borders, for import from longer distances, we see a lot of opportunities also in the form of hydrogen derivatives, so being ammonia, but also maybe methanol or e-methane. We are really open to anything, but it should allow for the injection of gaseous hydrogen on a transport network by pipeline in our country. That's for the import infrastructure. Now, you also ask a question on regulation. So indeed, we are going faster than the European gas package, and that's a challenge. So I already highlighted in my presentation that we believe we cannot wait on that gas package, but we must also be aware of the fact that the European Commission will come at some point with a definitive gas package, and we will also need to conform to that one. So the exercise that we've been doing is to, try to align as much as we can with the current proposal of gas package, but knowing that that one will also evolve in the coming years and coming months. And so we took from that one the most important and most interesting parts we found, and which are really necessary, according to us, to kickstart the market on the short term. Knowing that the rest of the package will also come, but what is maybe not required on the short term is maybe a bit less urgent and could come afterwards. So that's also the reason why we focused first on unbundling of the network operator as well as third-party access to the pipeline infrastructure. And on the name of the current initiatives, so the state of play, the current status is that we just launched a public consultation back in February of this year on the envisaged regulatory framework. Based on that consultation and feedbacks that we could collect from the market actors, we've been writing and building a draft law that has been validated by the government right before the holidays, and that one is now at the Raad van State, Conseil d'État. I don't know the name in English, but we are waiting for the feedback from the Conseil d'État, and the next step is then to introduce that draft law into Parliament before the end of the year.
Thank you, Maxime. Dr. Walter, also two questions for you. There was the question about the importance of the value chain in circular economy, and also the question from Air Products about contract for difference.
Yeah, I'm starting with contract for difference. I try to keep it short. Get in touch with me afterwards if
yes, keep it short.
If didn't answer your question. I mean, we have certain key industries with reinvestment needs, and we know where these reinvestments have to go to technology-wise, and carbon contracts for difference are a solution to make these investments happen now, covering the extra cost in investments and mostly along the life cycle of these technologies when it comes to operating costs, especially for direct reduced iron for the next, I don't know how long these technologies are planned for, 20 years, 30 years. And we have to ensure a certain price level for industry to invest in these technologies, and wherever we know that technology investment are without alternative, we're trying to forward them. This political instrument is highly expensive, of course. State guarantees for prices over such a long time period, where most likely the state will be paying most of the time. So what we're really hoping when we're starting the system for steel and for some chemical processes is for the European Union to catch on and to develop a system for industry carbon contracts for difference.
And the question about circular economy?
Circular economy. There's a lot of single topics in circular economy we need to address along the value chain. I mean, the technologies which we're focusing on here is without alternative, but along these topics, circular economy, of course, plays an important role, and our basic materials industry, they wonder how they keep secondary materials or more secondary materials, and there we're talking the long loops that really restart the whole production process. And they're getting more secondary materials. We will also need to talk about which industrial symbioses we're destroying with the new technologies. I mean, there's industrial clusters working together and shifting materials along business and industry sectors that are being disrupted now with new technologies and some byproducts not being there anymore. And you're right, there's a lot of things happening along the value chain, especially in the first few steps after the basic materials industry, and we have to address these, because here it happens a lot that makes it very hard, or in some cases impossible, to bring these materials back into the value chain as proper resources.
Tom, we know that the Netherlands are constructing or have already constructed a plan of circular economy. Is the whole value chain taken into account in this plan?
I'm not familiar, I'm afraid, with that, with the circular energy plan at the moment. It's not part of my work portfolio, so I can't really comment, I'm afraid.
Okay. Maxime, maybe you want to tell us more about circular economy and how your government is trying to incorporate this?
I can tell a few words. Well, circular economy is definitely key in the transition, because we talk a lot about energy, but we should also give some interest and traction to also material scarcity and how we use materials. That will be one of the next challenges, I think, together with water in the coming years. So that's also something we we are playing on and reflecting about. But honestly, that's unfortunately not the competence of my minister.
Okay, so Tom, we end with you with the question about the maatwerkafspraken. Can you give the Mr. that asked the question an answer?
Yeah, I can say a few things. Yeah, so of course this is a policy under development at the moment. There's a number of steps, the inventorization of steps of these tailor-made agreements. The next step is the developing a framework upon which some sort of support can be given from the government. Because although they're tailor-made, there needs to be some sort of system upon which policies and eventual potential subsidies can be given, and that these obviously need to be compliant with state aid rules. So there needs to be some sort of constraints and framework around it. But indeed, transport TSOs are going to be really important in this regard. And all I can say there is that the government, in a recent parliamentary letter just before the summer break, with regards to which provided an update on these tailor-made agreements, is that the government will provide the conditions upon which the tailor-made agreements can be deployed, and these will have a clear link with the work done in the PD team and for the MEEC project, the major national infrastructure projects that I mentioned in my presentation. In which TenneT were involved as a stakeholder. And what I can say is that if, for example, when analysing the tailor-made needs of the government, that some of the infrastructure are considered bottlenecks and are required, then the government has said that they would look to accelerate some of these MEEC projects in order to facilitate the tailor-made agreements.
Okay, thank you so much, and thanks everybody for your attention. We will now go for the lunch break until 1:30, and then we come back here to discuss the different technologies that can help us with decarbonizing the industry. Okay, everybody, we're going to start again with the second part of our conference, zooming in on the different technologies to decarbonize industry. And our first speaker is Dr. Andrea Ramirez. She is a professor of low carbon systems and technologies in the Faculty of Technology, Policy and Management at Delft University of Technology from the Netherlands. So I will give the floor now to Dr. Andrea Ramirez.
So today I have been asked to speak about CO2 utilization and what does it mean for accounting of emissions as part of our, pathways to actually defossilize industrial systems, and I use the word defossilization rather than decarbonization. So I think you guys have been discussing in the morning, and you all know there is no silver bullet, however much we would like to do it. We have a number of key strategies that we can use to try to reduce emissions in industry and, by the way, in society. The first and foremost will be to use fewer resources, so increase efficiency in process, not only energy efficiency, also material efficiency, of course, reusing, recycling, which is just, trying to extend the life time of products as well. Decarbonizing the energy sources, try to use energy sources like wind, PV, hydro, that do not have embedded CO2. And the third point, and where this talk is going to be focusing, is in the replacement of fossil fuels with alternative feedstocks. And if you look in literature and also the work that we are doing here at the university, we generally tend to concentrate in three types of alternative feedstocks: waste, biomass, and CO2, each of them with their own challenges, each of them with their own problems. They are not free lunches here. We understand there are limitations for the different kind of resources that are available or that will be available, but it's important to have a fair picture, we think, as fair as possible of what are those trade-offs. Now, the reason why we do that, and I assume this is also known for you, but just to avoid any confusion, is because in industry, of course, we use fossil fuels for heating or for cooling. So we use electricity, we use steam to manage the processes, but there are what we call non-energy uses of fossil fuels, and we are interested in the carbon in the molecule, the carbon that is in coal, the carbon that is in natural gas, the carbon that is in fossil fuels. And we in industry use the carbon to produce a lot of the products that we use in our daily life, going from dishwashing, crayons, gasoline, shoes, textiles, cameras, all kind of plastics, all of that. If you follow the life cycle, you will arrive at some point, at least for most part of it, to some kind of, fossil carbon. And therefore, we haven't figured out a way to produce all of these products without a carbon molecule. Some of them we are working on it, but others, we need to see, okay, how do we produce a plastic that doesn't have carbon in the molecule? We haven't figured it out. So we are saying, instead of speaking of taking out the carbon, because we need the carbon in order to have the product, we would like to actually change the source of the carbon. In that sense, and this talk is not going to be speaking directly about biomass or the carbon in waste, although a lot of the points I'm going to point out today also can be applied there. I'm going to be speaking about CO2 as an alternative raw material that we can use to actually produce these chemicals and materials. And therefore, I found a lot of people come along with the question, okay, but is that environmentally sound? And the problem with that is that CO2 utilization is not one thing. CO2 utilization is actually an umbrella concept. It's almost as asking, is all industry environmental sound, and put all the processes and all the products and all the locations under one concept. It's almost impossible. So when you look at CO2 utilization, then you are looking, at having CO2 using energy, and you are going to have a low carbon process and product, and it has to be, energy that does not produce a lot of CO2. So in this case, for instance, renewable energy, we will need the CO2. Question, where does the CO2 come from? Does it come from point sources? Does it come from the atmosphere? Does it come from the ocean? Where is it coming from? And then if you have CO2 and you have energy, and most of the time you also need hydrogen, because what we use in a lot of our molecules is not only carbon, but also the molecule itself has hydrogen. And you can produce food products, you can produce fuels like methanol, you can produce chemicals like plastics, you can carbonate materials to produce, for instance, aggregates. So this is what we call CO2 utilization, and you can do that using, thermochemical conversion, electrochemical conversion, biological conversion. So it's quite a lot of pathways to go from this point. Hopefully you see my mouse. Maybe I need to, let me just put it, it's a laser pointer, from this point to this point. Now, what makes CCU special with respect to many options is that most of the CO2 technologies, not all of them, but most of them are a low TRL, I mean technology readiness level. In other words, they are still at the lab or they are at the pilot. You can just not go and buy it at the scale that you would require. Therefore, scaling up and dealing with the uncertainty that you have when you are trying to compare and benchmark processes that are not yet commercial is a key characteristic of any performance assessment, whether it's an environmental assessment, a carbon footprinting, for instance, or whether it's a techno-economic analysis to try to understand whether or not there are business cases. Now, in this figure, and this is from 2017, so the data comes a little bit before 2017, so there has been some movement in TRLs, but the general picture is here. So in this side, you see the different pathways that you can apply to convert CO2 into a product. And in this side, you see the technological readiness level, with one being it's just an idea. It hasn't even gone through the lab. It's just in paper to 9 and beyond, when it is commercial, I can apply it in an industrial condition and just buy the technology. And a lot of the technologies that you see are here and are moving from this direction, towards the right. Now, what is the challenge for this kind of assessments? And I name this because life cycle assessment and CO2 footprinting is an ex-ante assessment if you are trying to understand how a technology that is not commercial will perform in the future. Then the challenge that we have is how do we give you, policymakers and stakeholders, enough information to make decisions about pathways when there is little amount of data. So what you have in this figure, and I think it's known for many of you, they have different stages of designing of R&D of technologies. The more you move towards the right, the more data that you will have. But as you move toward the right, the less degree of freedom. That is, you have taken decisions on how the technology will operate, what kind of system it will be, at what temperature, at what pressure. So you have less and less possibilities to make changes, or you have possibilities to make changes, but that will cost you money. So if you can make changes early on, theoretically, it will be less expensive than having a technology completely finished and then discovering that there are issues, for instance, with the environmental footprint that will send you back to the drawing board. Now, one thing I already said, technologies at the early stage, like most CCU, will have large uncertainties. And contrary to most belief, research tend to increase uncertainty. And the reason why is because then you begin to see the things that you don't know. So at the beginning, you don't know what you don't know. And then you begin to realize what you don't know. And then that realize, oh, wait a second, I have an uncertainty here and there. Complex systems, including industrial systems and energy systems, tend to have some irreducible uncertainty, which is intrinsic or practical. With that, I mean, it's not possible, however, we would like to really 100% be certain where are you going, because the systems may exhibit some behavior, which means that when you put all the parts together, they behave in an unexpected way. That is a characteristic of a complex systems. And in many of these systems, you have unquantifiable uncertainties that actually dominate what you can quantify. So, the unknowns. The other thing I want to say, just to be here, is there is a confusion between having low uncertainty and high quality, and they don't mean the same. You can have high quality with high uncertainty just because it is a high quality study that is reflecting you what the technology, for instance, an LCE of a technology at TRL 3 or 4 when it's still on the pilot, can be with the base state of the art approaches and still have high uncertainty in the results. And the quality, of course, relates to fitness for function, and so how robust are the results. That as a background of what I'm going to tell you and applies to all early technologies. Now, what we see and what the discussion is, and you may have had it this morning, is that we tend to see CO2 utilization, both, depending on which part of the chain or what kind of stakeholder you are. For some people, it's a solution. For other people, it's a distraction to reach climate mitigation targets. And there is a whole disagreement in literature on what is the role, what are the benefits, what are the bottlenecks of different CCU options. And this comes from the latest IPCC report, Working Group 3, where they actually, there are a couple of places where they explicitly name CCU. And one of the conclusions, for instance, is that the global CO2 utilization potential is at this moment limited around 1 to 2 gigatons of CO2 a year for use of CO2 as feedstock. But they say, well, it could increase up to 20 gigatons by mid-century, by 2050. These are what I have here in the figures are actually two different publications, kind of in the stream, the Global CO2 Initiative showing a huge market potential and also a huge potential to increase emissions, and other publications, like the publication from the Klein et al., showing a much lower limited role for CO2 utilization. So where does it come, this kind of mixed messages? Well, if you look at the ranges right now, there are some people going, it's almost nothing, 0.5% of the reduction to, it is actually significant with 10%. We see that in those analyses, there are differences in the products that are included in the analysis, where I include things like CO2 enhanced oil recovery or not, whether I include plastics or not, whether I assume that the plastics are recycled or not. There are also differences in system boundaries. That means, do I take into account what happens with the end of life of that product or not? Indirect impacts are also taken or accounted for in different ways. Reference, reference lines, reference scenarios, reference technologies are also chosen in a different way, and the timelines are also kind of changing between different publications. So it's not surprising that if you put 2, 3, 4, 5 publications and you have this list of difference, that all of them show you kind of a different picture. Now, what I found quite nice, well, I found many things nice about this publication, so I recommend for those of you to read with, of course, critical mind, is this, because I think it makes a nice picture of what do we need to look when we look at CO2 utilization, especially when we are trying to understand what will be the carbon footprint. And then we have things like we need to look into, what are the sources of the CO2? How is the CO2 actually being captured? If you need to capture it, how do I utilize it? What am I using it for? What is displacing, and how much the carbon will stay in the product? So those are all the things that systematically you need to address if you want to understand what is the contribution of a pathway to climate change targets. Now, one thing that we see, and I see it, by the way, not only for CCU with many ex-ante technology assessments, but CCU is an example of them. It's changing slowly, but it's still there, is that many studies often assume what we call non-realistic conditions and partial system boundaries. And I would like to just address those. So let's assume, and this is a picture of what we generally see, not in all studies, but many of them, just to explain what the process is. You take CO2, you actually need to purify it. You can put it in a low TRL technology, hopefully in the future will be a high scale. This is an electrolyzer that uses CO2, water, and electricity. The water is not divided here, but you CO2, water, and electricity, and produces directly a product, for instance, ethylene, which you then need to separate, you need to purify, and then you can sell. And then instead of using naphtha, now you are using CO2. Now, when I look at the TA and the LCA, the techno-economic analysis, and the life cycle analysis, you realize several things. One, a lot of people are assuming that this CO2 that you need is going to be a gate. So you are going to have it in your industry there available. It's going to be at the conditions that you need it. It's going to be cheap or for free because CO2 is a waste, and it has no carbon footprint whatsoever. Another thing that people are assuming is, for this process to make sense, it needs to use renewable. It needs to use low carbon electricity or zero carbon electricity. So a lot of people say, well, in Europe, we are changing this. So let's assume that this energy just gonna come from wind and or solar. That's one assumption, but then they began to assume extra things, like it is gonna be available for you. It's gonna be extremely cheap. It's not only gonna be cheap, it's gonna be continuous. This is intermittent, but the energy I get here is 24 hours 7, and it has no carbon footprint. Then we know that this is not purifying, and several studies actually don't put a lot of attention. What do I need to separate and upgrade my product, and how much energy and other materials do I need to do so? And the user phase, what happens with the product? Some people put just the boundary here, and then we don't know where the product is on because that's my boundary gate. Okay, there will be many reasons to justify this, but in general, it presents just a partial view, and it doesn't allow you to really understand where are the bottlenecks of the technology. It doesn't mean that these steps are per se bad. We have that today. We need to have a raw material. We need to transport it. We need energy. We need it to have it continuous. We need to separate. We need to upgrade. That's what we do today in industry. So there is no reason why we produce in a different way, we will not have kind of same conditions, at least at the rough level. Now, at the university here, we are dealing with several of these aspects, trying to understand for CO2 utilization, where are the bottlenecks and what will it mean to actually try to understand those. And I don't know how many of you are chemical engineers, so I'm not gonna go into the detail, but let's say this is a process that we have designed to produce, use CO2 and to produce ethylene. And it was just an exploratory study. We wanted to understand whether it matters. What matters? Where it matters that I don't have a continuous amount of electricity. So if I'm not going to produce continuous, but I was going to just follow the load and do it flexibly, what will it happen? So this is a preliminary results. We have, we have moved ahead on this, but I think for the purpose of this lecture, this is enough, because I wanted to show those things. Even if you are not, a chemical engineer, you will notice that this is a much more complex picture than this. And the reason why is because in order to make, this is a highly integrated in terms of heat and flows process. We try to use everything as much as possible. As soon as you want to be flexible, a lot of integration actually makes you lock in. You are not as flexible because you have been designed to work optimally in an integrated way. So in order to run the same process in a more flexible way, we needed to let go a little bit of the flexibility. We needed to reduce heat integration. We needed to reduce the size. So the main point with this is when we just challenged the hypothesis that this process and this process actually are the same, but you realize they cannot be run and designed in the same way, you do get a different plant layout. You get a different economics. You get different environmental footprint. So assumptions that you take on whether or how energy or materials are fit into the process will affect how on what extent the process actually is techno-economically feasible or environmentally sound. Now, the title that I was asked here to present and discuss today was accounting, accounting of emissions. And if you ask, well, what is accounting? Accounting isn't it fundamentally adding, subtracting, multiplying, and dividing? We all learned that really early on, primary school. So how difficult it could be to take two numbers and just add them or subtract them or understand what is the scaling up? Well, not as straightforward as it looks like. So the first step in a carbon accounting is actually defining what am I counting for? What is inside? What I'm interested? And when you go to literature, there are many system boundaries that you can actually consider. You can just go and do the closest and the narrow system boundary. That is what we call in LCA a gate to gate. So really just the company. If you have, for instance, biomass, very common people tend to do gate to gate and just expand a little bit to assume that the biomass is neutral, and that is an assumption. And that's an assumption. You can just not assume it happens because it's not inherently neutral, because you need to transport it, you need to actually move it from A to B. So this system is not inherently neutral. It depends a lot how you grow this biomass, which biomass it is, where it is, and how did you move it from A to B. But people tend to avoid this and just take this red with this and call a system boundary. You can do a cradle to gate, taking this into account, or you can do a cradle to grave and taking into account the where the carbon ends at the end of the life cycle. Now, if there are a couple of messages that I would like to give you is that the system boundaries matter. It's not, it's a choice that you make early on in a life cycle assessment, and it does has consequences for the whole life cycle assessment afterwards. And this is a publication that Samantha Tanse, who now is working with Bellona, did for her PhD thesis on when are negative emissions. And she has a really nice example, so I will advise you to read the paper, but of how having exactly the same system and just changing and playing with the system boundaries gets you from a system that is producing actually CO2 to a system that is negative, to a system that is neutral. So you can actually, without changing the technology, just by considering different systems, tell an amount that is true for that system boundary, but does not represent the real environmental footprint of a technology or a system. So we are arguing, and where possible, work with as expanded system boundaries as possible. You know, try to include as much as possible as you can, because that will allow you to understand where the trade-offs are happening. The other thing that I think is quite interesting is that those are physical system boundaries, like cradle to grave, but there are also a system of assumptions that impact how you deal with this. So now how I allocate impacts, what do I think is more important? How am I transmitting uncertainties? What is the data quality? How is my accounting practices? What are the regulations that exist in place? And even the language in which you are speaking can influence how you actually communicate information. A typical issue when you do accounting, especially accounting of carbon, and this is not for CCU, this is in general, but it has a big implication for CO2 utilization, is the confusion between reduction and removals. And by this, I don't want to say you need one or the other. Actually, we need both. We will need carbon reduction. And in carbon reduction, you need to realize you are still adding carbon into the atmosphere, but it's less than it would have been emitted otherwise. And then you have carbon removal, where you really take carbon from the atmosphere, and it's a physical process. It's a concentration, what we have in the atmosphere. You cannot decrease a concentration with an imaginary flow. You need to physically take CO2 from the atmosphere in order to decrease the concentration, okay? What happens is that CO2 avoidance are often misinterpreted. And that is for people who do not understand how LCA think. It looks like logic until you really try to understand what happened in the process. So what generally you assume, and for CO2 utilization, is often the case, that I'm producing a product that is replacing something else in the system. And what people tend to assume is that if I'm producing A and I'm replacing B, then maybe I can credit for the emissions that were not emitted. So I quantify the emissions that would have occurred if this product had been produced. So would have. And those I accredit to me. And depending on the system boundary, if I do that, I can easily get a negative number. But that negative number doesn't mean negative emissions. So when you do CO2 avoidance, you are not physically doing an inventory or actual changes on physical emissions. You are actually looking at relative changes between systems. And this is a typical example where you take into account the life cycle of a product that is being studied. You are crediting for something that is substituted. You have 3 kilograms minus 4 that gives you minus 1. The minus here is not a negative emissions. It just shows the relative change in emissions compared to the most likely scenario. So it is a relative number. I think if you guys get that, I'm very, very happy. So what relative number I'm comparing to? And that is another issue that sometimes comes is, what product am I substituting and what is the role that I'm giving to that product in the system? So let's say that I make methanol out of CO2. So it's a CO2-based methanol. And then I will say, well, what is, how much emissions did I save? How much emissions did I avoid? Because the methanol is a fuel, will be combusted and the carbon will finish in the atmosphere. And most people will say, well, you do this. You take the CO2-based fuel. Today we use gasoline, so we can compare these two systems. And if 1 unit of CO2 replaces or displaces a unit of gasoline, then that will be what I'm avoiding. The reality, of course, is that if you have some technology that will be in 10 years or in 20 years, maybe the most likely competitor is not going to be gasoline. Maybe you will be displacing biofuel. Maybe you will be displacing hydrogen as a fuel. Maybe you are going to be displacing an electric vehicle. Those are all the scenarios. But if I look at the delta here, what the delta between these two, or between these two, I will get different levels of displacement. So it's not one because it's a scenario-based, it's reference-based. So what we are asking, and right now, and we have been recommending to several stakeholders, is of course you can do gasoline, but look what will be the most likely competitors beyond that, and try to understand whether your results on avoidance will only be positive if you are displacing that unique fact, because then how are you going to secure that that happens? The other point, of course, is that in a system, you may have different services. So I can have methanol as an energy storage. So when the wind is blowing and I have that extra energy that I cannot use, why don't we use that extra energy, mix it with CO2 and produce methanol, so that when there is a shortage, I can burn the methanol and produce more energy, typical energy storage. If you do that, then it doesn't make any sense to do an LCA where you compare the CO2-based fuel, which now is an energy storage technology, with something like gasoline or biofuel, because those are no energy storage for the power system. And there won't be energy storage for the power system. So in that case, when you do the comparison, you may look into batteries, or you may restrict it to hydrogen electric vehicles, you may look into compressed air, hydro pumping, but you need then to look at the system and the service and realize, am I comparing apples and apples and oranges? Other issues that you need to be aware when interpreting substitution is that it is often assumed that the displacement will happen in one-to-one basis, but this may not always be the case. It could be the case, but it's not always the case. You may be actually adding instead of displacing. And the other thing, of course, is the benefits of substitution will change over time. And the reason is, if I'm displacing gasoline, if we're really transforming the society and we really do the homework we should be doing, in 2050, we will producing less and less and less gasoline. So I will be displacing gasoline less and less and less while producing the CO2-based fuel. So that kind of benefit is actually time-related, how your baseline is changing as well. Substitution effects are not inherently permanent. That means in many cases, you need policy instruments that allow the system to stay there to keep the substitution effect. If you take the policy instrument, will the system still go for that solution, or will go back to the original solution? That's more a policy question. And often it's assumed that we know what we are displacing. That is okay for the short term and maybe for the medium term, but what about the long term? And this was work that one of my PhD students is doing on replacing ethylene. And he just looked into what technologies are we doing today. Ethylene is a basic chemical for production of plastics. What are we researching? What is the R&D in ethylene? And we found actually 53 different routes which are now being studied to produce ethylene. Of these, only one from CO2 coming here, biomass here, and waste here. So, of course, you are not going to do 53 different comparisons, but this is just to let you know, the future can go in different directions, and then we need to be very critical on what are the reference studies that we are looking at. The other thing when carbon accounting is, and we hear it a lot, that it will be good if CCU could deliver negativity. And for negativity, and you have the reference there, it comes also from Samantha's thesis, we are asking at least 4 minimum principles, and I assume they were discussed in the morning. I'm not going to read it, all of them, but whether they are physical greenhouses are just taken out of the atmosphere, the permanence, the life cycle thinking, and of course that is negative when you do a physical balance. Many CCO technologies cannot fulfill these 4. Some can, if you go especially into carbonation, but then there are also other conditions that need to be addressed. Some can, but most cannot. And if they cannot, then they are all playing in the displacement and in the need to still have carbon. And we can say, well, don't do it, but we still have an issue. How do we produce these products that need the carbon in the molecule? So I think the disclaimer for now is be very careful with the negativity. It doesn't mean that they cannot be beneficial, but they not be as beneficial as some people are selling. One important point, of course, is that removals are defined by the permanence. And one typical question I tend to receive in this type of talks is how long is long enough? And I know that we now are going, instead of speaking of permanence, is speaking especially in CO2 utilization, we are using the term durability. So how durable is the carbon in the product? And how durable is the lifetime of the product? And what I have here is just typical lifetime of products. So in our society, unfortunately, we don't replace things when they are broken. We replace things for many other reasons. So we want to change car, not because the car doesn't run anymore, but because we found a new car, it's nicer color, we got children, we want it bigger, or we get out of the car because we want to go into another way. So cars, for instance, average lifetime right now is around 25 years if you count that you sell it and sell it, but it doesn't mean that the car could not last longer. Buildings, 75 years, urea, within a week of being applied to the soil, the carbon is leaving the soil and going into the atmosphere. Some packaging plastics, we know that some of them are even lower than 6 weeks. Fuels, where as far as we consume it, so it depends in the stock, but we have relatively short stocks. So how much is the carbon in the product is not only related to, a plastic can last a long time, but if I burn the plastic, if I incinerate it, the carbon will be in the atmosphere anyway. So one special point is that there is no correlation between the time horizon of a product, so the lifetime of the product, and the atmospheric lifetime of CO2. So according to the IPCC, more than 50% of the CO2 is removed from the atmosphere by natural process within a century, but around 20% stays for many millennia. So that means that the time that we select to speak about permanence or durability, depending on the group you are in, it is actually a social construction. It's a policy decision. So if you look at UNFCCC, we are speaking about 100 years to consider something permanent. If you look at the PIF guidelines, the European PIF guidelines for products is 300 years. The International Reference Life Cycle Database is speaking about more than 10,000 years. Many life cycle assessment, we look at 100 years, although we can do assessment at 550. But 100 years is a number that is at this moment commonly accepted because of the Kyoto Protocol. 100 years is also a little bit beyond my lifetime, or at the end of my lifetime. So for people and for applications and for policy, I think makes sense, but it doesn't mean that it's really durability in the more scientific point of view. Whether it's 300 or 200 or 50 or 10,000, I will put here in the table that is not an LCA problem. That is not an LCA accounting problem. That is a value choice from us as a society of how we look at impacts in the future. If you select a very shorter time, and I have heard people speaking about permanence in the terms of 50 years or even smaller, say just 50 years is permanent, then you want action. There is a reason why people do that, and you will promote high action in the short term. But in that kind of system, if you do an LCA, temporal storage will gain. Did you have it for 40 years already? Very, very good. If you as a society select a longer time horizon, 100, 300, 10,000, then temporal storage from a climate point of view has less value in the assessment. So this is something that as a society we need to take a look into. We have the methodologies from a life cycle assessment to account for this when it happens, but that doesn't mean that we are the ones who are deciding. The other option, and I know that I'm throwing a lot of information this, and I'm almost done. The other option that is being discussed is, but let's recycle. I mean, if we recycle, we are keeping the carbon outside the atmosphere. And how realistic is that option? I think conceptually, you can actually design systems where that will happen. But the issue with a lot of this is, can you take it really in practice, and do you want to play your carbon budget in that until we don't have it developed? And the example I have here is about plastics. And we know that we have the technology, we have the resources, we have the know-how. Everyone is speaking about how plastics are really bad for the environment. Why don't we recycle? Well, General in 2017 took a look at what happens in the system, and they realized that, yeah, well, of all the plastic that we have produced, which is thousands of tons, historically around 600 megatons has been recycled. That sounds like a huge amount, but that's only 9% of the plastic produced between 1950 and 2015. And of that 9%, only 10% were recycled more than once. So if we want plastic to be a way to do long-term storage of carbon, it will have to go from more than one cycle. And my question also for you as stakeholders is that will require that we keep custody of the carbon if we are going to credit that. Who keeps custody of, the carbon goes from A to B, the plastic moves from the US to Europe to China and back. Who knows where the carbon is? Who actually is keeping track of that? Where if suddenly it's supposed to be recycled but it's incinerated and the credits were given for permanence, where do we go and say we take the credits back? From whom, if it happened in the third cycle? So the issue with this is we are not careful. The system can shift from carbon sink to carbon source as well if we begin to put also in the recycling a lot of fossil energy. So you have two issues that you have to address as a policymaker. So technically, yes, maybe socially very difficult. We still don't manage to recycle a lot. From a policy monitoring and modification point of view, will be a really large city. So something that you can say, of course, make the systems as easier and as simple as possible, but unfortunately, simplicity is not how we design most anthropogenic systems. So these are issues that we really need to tackle when we are speaking about carbon footprinting for CCU, and whether you link, which is not necessary, whether you link CCU, for instance, to permanence or a solution for negativity of for neutrality. So just to finalize, unfortunately, there is no unique answer to the question of economic or environmental performance of CCU. It is very context and very product dependent. We do see it could be a contribution that is direct. So when the CO2 is inherently sequestered in the products, that applies a lot for mineralization products, for carbonates. Then the CCU can take credit for the CO2 that is embedded in the product, meaning the CO2 emitted in the whole CCU chain, and this tends to be very favorable. And generally, we argue there is an indirect benefit, which is that you take the CO2 and you don't need to have fresh carbon from fossil sources. So although the CO2 is re-emitted back at the end of the life, the product replaces the current fossil-based products. In that case, the CCU will take credit for the CO2 that was not emitted, minus the CO2 that is emitted in the utilization change. Theoretically, again, but you really need to look in it. This could be neutral. This could be negative so you can combine direct and indirect if it keeps the CO2 permanently in the product. But if the carbon is from fossil origin, the reality is, however round you want to do, the process will add net fossil CO2 to the atmosphere. Theoretically, it could be less. The fresh fossil is used, is still new fossil, going from the geosphere to the atmosphere. The indirect benefit decreases as fewer fossil fuels are in the economy. And of course, there is a question and a debate at this moment on if we have unavoidable emissions, could we use those for CCU? And if so, what does it mean? Now, I think this is my final slide. And just to summarize, I would say the environmental performance and as part of that, the carbon accounting of CCU is a function of the product that you are considering, the time the CO2 is stored in the product, the longer, the better. the source of the CO2, whether it comes from air, from fossil, from bio, from geo, the footprint of the energy that you require to actually make the utilization. So CO2 is thermodynamically very, very low. It's the product of combustion, so you need to put energy for most products, except for instance, mineralization. But in that case, you generally need energy, heat, pressure, but you also need hydrogen. And what is the footprint of hydrogen will determine what is the footprint of the CCO, which means that if you want to apply CCO at large scale, you need to have, the grid decarbonized, and you need to have low carbon hydrogen to make this, a carbon sound solution. Then the issue of displacement, what, when, replacing or adding, and also look at all impacts, but also other benefits. So it's not that I'm saying it's not gonna happen, not gonna happen. We still need carbon in the products. It's not a straight, picture. What we can do is a very difficult transformation. I think the transformation of the industrial sector. But I think we are aware of some of the issues we need to be looking at. So we know this is important. We can't just say, well, it's too difficult. Let's not discuss it. We need to do it, otherwise we will finish in a world with CCO exactly in the same place where we are now, or even worse. And that was the end of my presentation. Loie?
Thank you so much, Andrea. Do you still have 5 to 10 minutes for questions?
Oh, I spoke a Spanish speed, so hopefully I didn't lose everyone.
Do you still have time for some questions?
Yes.
Okay. We have time to take 3 questions. Are there any questions for Andrea? Okay. Please, then Mark. One other question? Final chance? Okay. 2 questions then.
Hello, thanks a lot for the presentation. So Aymeric Raymond from South Pole. We're working on 1 or 2 waste-to-energy projects that have both fossil and biogenic sources of CO2, and that are looking at a combination of solutions of both usage and storage. Are these cases, these are quite complex from an accounting point of view, and I was wondering if you had any experience or examples that you could share on those.
So I think one of, we have been working on that. We start with an understanding how do we make this comparison. What make it quite complex are 2 things, or are 3 things. The first one is the need to then start separating the flows, the biogenic from the fossil, not because the CO2 molecule behaves differently in the environment, but because of accounting and because we are trying to shift the system from fossil to biomass, so you want to know how are the shares being distributed. So you did different benefits or allocate in a different way, depending on that. It has nothing to do with, the CO2 molecule, whether it's bio or geo, physically and chemically behaves in the same way. So the need to separate those flows, that's one. The second point that is a little bit tricky to handle is to handle how do you do the system boundaries. So right now, the guideline in life cycle assessment is that you use a waste that then you don't allocate any environmental impact to that waste because the environmental impact was already allocated to the main product. So you try to avoid tower counting. Now the question comes whether in a circular economy that concept still holds, where we need to allocate, and how do you actually draw your system boundaries? So you should not, even in a normal LC, allocating a carbon footprint to the waste, but what about the transport? And where is it coming from? And how do we handle those steps in there? So system boundaries become to be a very tricky one. The third one is a little bit more in the technology place, but there are already quite a lot of efforts. And I think valorization of waste, for me, is something that should happen. But the question is, what do you want to credit it for? And my experience is people are trying to kind of exploit the chicken and trying to have as much as possible from the concept. And then you get into, can I really prove that? So it's environmentally sound because it avoids, it displaces, because it handles. So now it doesn't only display the treatment of waste, but it displays also the use another product. How do you account for that? So displacement keeps being a big problem. But I'm not certain I'm giving you a lot of tricks and highlights, but I say, well, keeping the flows separated, expanding system boundaries, have a bit of scenarios where you can understand what is the influence of those in your process. At least we'll give you some highlights. Happy to discuss that later on if useful.
Okay, thanks a lot. Last question.
Yes, my question is about the necessity to reach massive net negative emissions as written in the reports of the IPCC, which has not been taken over by the Paris Agreement, but which are still in reports and getting more and more the more recent the report is. How do you evaluate, let's say, the actual policies to use or maybe even abuse CCU not to mitigate enough and to avoid the task of net negative emissions?
I think well, let me try to see if I understand the question, but I think we kind of mix three different things. On the one side, we have the need for carbon to produce products in the future, where your carbon comes from biomass, and then we can have a discussion about sustainability of biomass, about waste, and then we can have a discussion about logistics and also sustainability of waste of CO2. You need the carbon. And CO2 utilization started as part of green chemistry, green industry, to try to move away from fossil, but really trying to avoid toxic routes developing of industry. And now we have moved from there to something that is like, and is there because of the negative emissions. And I don't think that is the case. I think we should not be reaching the case where we are just producing products to get the negative emissions. That is a really strange thing to happen. So you have a demand that hopefully will go down. You still need to produce carbon products to satisfy that demand. Some of that carbon will come from waste. Some of the carbon will come from biomass. And I think most likely some of the carbon come from CO2. The change will not be resulting in more emissions than what we are doing today, because that also doesn't make any sense. And if you have those as basic conditions, I think we will reach quite far away. And now people say, well, and now it has to go negativity. Well, some products can do a bit of negativity. First, you have to do reduction, and then you have to, while at the same time kind of decreasing demand and supplying the demand in the most sustainable way. And then it comes negativity. So I think I think without reduction, that negativity doesn't make sense. So we cannot get to a point where we are emitting and emitting and emitting more and just thinking that we are going to reduce it, either producing products or storing on the ground. You need to reduce as much as possible. And then we can speak about, the rest. But otherwise, we are emitting at 30%, 20%, 50%, 5% CO2 concentration in a stack in an industry, and then capturing at 400 or 500 ppm at the other side. That's really, really, from a thermodynamical, economic, space, environmental justice, doesn't make sense. We will need negative emissions, but if we don't do reduction, yeah. Okay. I want to say
thank you so much, Andrea, for your interesting speech, and thank you for joining us online. We need to proceed to the next speakers, so bye. The next discussion is between Tom Mikunda, who we already saw before noon. He's a senior policy advisor at the Ministry of Economic Affairs and Climate Policy in the Netherlands. And he will be joined by Michelle Prins. She's the program lead on sustainable industries of Natuur en Milieu, and a Dutch NGO. And they will talk about the governance system of CCS in the Netherlands.
Okay, great. Okay, well, hello again. And well, maybe just now a bit of a deep dive into one of the technologies that is, as I mentioned, has an important role to play in Dutch industrial climate policy, and reaching the 2030 and 2050 goals. But this is a bit to focus on the governance model of CCS, so more about how the Dutch government is implementing CCS, and what the role is in climate policy, and what are some of the national discussions going on about CCS. So CCS is, at least its deployment in industry, is seen as a bridging technology or a transition technology. It's a cost of it's obviously recognized as an end of pipe solution for many in industries, with some exceptions. But it's a cost-effective, a cost-efficient, cost-efficient solution. CCS has been a controversial topic, also during the climate agreement or the discussions that went around in 2018 and 2019. And of course, because well, the industry and also the NGOs and the government were around the table, concessions had to be made about how CCS would be used and how CCS would be deployed. So CCS is predominantly seen for use in industry sectors. So that's where, particularly for industry sectors where no other cost-effective alternatives exist. There are discussions about how to decarbonize the power sector, but CCS involvement there may be particularly related to the use of producing low carbon hydrogen for use, for example, in gas turbines. Based on the discussions, it was chosen to have an industrial policy for CCS, or the SDE++, which would cover the capital and operational expenditure of deployment of the CCS projects. Something that I think Michelle will also talk a little bit about is how the deployment of CCS, or the deployment potential, if you like, has been limited to ensure that it doesn't drown out other cost-effective alternatives. One of the ways it's limited is a cap on the amount of CCS projects that can be subsidized, currently at 8.7 megatons. A check, or as another one of my slides will show, that CCS can only be subsidized if there's no cost-effective alternatives within the same deployment timeframe and within similar costs. After 2035, be no new subsidies granted to fossil CCS projects. And as of 2023, there will be separate allocations for the technology budget in the SDE so that CCS projects will compete with one another, but they will not compete with other sustainable energy technologies. Then we see a role for negative emissions with direct air capture and biomass for CCS. Well, after 2030, I mean, we're now sort of in the development phase, and we are supporting research and development projects. But it's sort of after 2030 when we expect these to become industrial projects, also with the development of regulation from the European Commission and the necessary incentive schemes for negative emissions being developed. CCU, we have now CCU projects, particularly in the agricultural sector, so greenhouses that need elevated CO2 emissions to cultivate crops or accelerate the growth of crops. The storage of CO2 in the Netherlands is limited at this moment offshore due to public perception issues. And the offshore storage capacity, we have considerable offshore, theoretical offshore storage capacity, both in depleted gas fields, say, and aquifers. Maybe just to show a quick slide about the SDE, how the SDE works. So the SDE covers the both post and pre-combustion CCS projects at the existing and new industrial installations. It covers the capital and operational expenditure of the projects for 15 years. And it does that by bridging the gap between the current or the expected market revenue, which in the case for CCS projects is the ETS price. The SDE was actually originally adapted for renewable energy production, so in which case the market revenue was the price of the electricity production. So a similar approach has been taken, whereby the SDE bridges the gap between the incentive provided to deploy CCS for the companies, and if you look at, for example, on this slide, you can see. So, for example, the top blue line will be the cost of deploying the cost of doing the CCS project. The green bars will represent the revenue or the incentive provided by the ETS, and the purple bars are the subsidy that would be given, calculated on a yearly basis. So the projects with the lowest reduction costs have a highest chance of subsidy, because it's based on a euro per ton avoidance. And projects have to be realised within 6 years from the subsidy approval. At this moment, there's no export for CO2 for storage outside the Netherlands allowed to be subsidised, because of the need for bilateral agreements or arrangements, or whatever that turns out to be that we need. Something that's important is that the industry is also given a tariff as part of the total capex and operational expenditure. They're given a transport and storage fee that they can then pass on to the transport and storage operator. One thing I think we want to zoom in a bit today on is the so-called sieve of technological alternatives for CCS. This is an agreement made in the climate agreement, which shows that a sieve will be used, and there's a picture below which I'll explain a bit later. That CCS is only subsidised where there's no demonstrably cost-effective alternatives at that particular time, in order to find a balance between displacing other clean technologies, but also while exploiting the reduction potential that CCS offers for meeting the reduction targets at the short term. And this is a study that we conduct every year on using independent advice. In 2020 we developed a methodology in order to conduct this, and the methodology includes a number of criteria upon which we evaluate the different technology alternatives, which is in that smaller blue box on the right hand side of the slide. So these alternatives are not, these can be added to should other technologies, but these are the alternatives that were, for example, evaluated last year. Of course, like these alternatives are looked at in specific implementation roles in different industries, so obviously in a very quite detailed study. So they're assessed against a number of criteria on the left-hand side. So in theory, if you look at that diagram, sort of the diagram, the ARRRA, the CCS requests. So basically, in theory, and it doesn't quite work like this in practice. The sieve is actually before the applications take place. So the sieve is used in case, for example, there is an alternative found for pre-combustion CCS in, say, for example, in hydrogen production, say, for example, green hydrogen. Then there is for all intents and purposes, should that come out of the study, then it would mean that the minister would have to consider closing a particular category of SDE projects, which could potentially close out a particular type of CCS project for gaining access to the subsidy. So yeah, so if we look at that sort of this flow chart on the bottom right hand side, so the SIV would be well, is already actually upfront applied to the different categories, which mean that the minister would decide, right, this category cannot be opened. And then after that, the applications are evaluated based on their subsidy intensity, and then the application, sufficient subsidies can be given to CCS projects within the ceiling of the 8.7 megatons, which I had in my previous slide. And that's a total maximum, so not an annual maximum. So this is one of the ways, and I think Michelle will talk a little bit about how the SIV works and what the NGO perspective is on this, on the SIV. A little bit about the governance of infrastructure development, which is of course really important, and it's a really new area. It's critical for CCS deployment, and a lot of the focus in previous years has all been about exciting capture technologies and a cost of capture, and often it felt like that the cost of infrastructure and the net needs for getting the storage sites ready were quite overlooked. It was often found, well, the storage sites are there, so. But I think what we, in the Netherlands at least, we recognise there are actually some challenges, and transport and storage infrastructure needs a lot of attention. To say a few bits about how the government, the Dutch government, looks at the development of CO2 transport and storage infrastructure. Well, the involvement of state-owned enterprises, EBN and GasUnie, and also the Port of Rotterdam, were seen as sort of market makers in the Porthos project, because the Porthos project actually predates the climate agreement, at least the initial stages. And at that very time, sort of 2018, 2019, there'd been an awful lot of work put into CO2 transport and storage infrastructure around the Rotterdam harbour. The Rotterdam harbour had its own regional targets and therefore own ambitions to develop CCS. Even though at that time the ETS price was very low, and the road CCS project on the coal-fired power plant had been cancelled, and which was actually sort of the main, if you like, the main driver for the development, and that project was cancelled. But really, it was decided that I think it's very commendable that the government decided, together with the state-owned enterprise and the Port of Rotterdam, that somebody had to take the step to kickstart CCS in that industry, because the roadmaps suggested and all the evaluations suggested that there really wasn't any other way to meet the regional but also national climate targets. So the first case is really a market maker, and that was the Porthos project, where the state-owned enterprises were involved and take the lead, and the government provided direct financing to get that project off the ground. But it's not a structural role. That was as a sort of a one-off to create the market for CCS. But since then, the government's been very clear that they'd like to give the market parties themselves the room to develop CO2 transport and storage. Because the market is as well placed to take that risk. If you create the conditions, the economic conditions, through, for example, the subsidies provided by the SDE, then the market should be able to develop, cope with the risks and take the lead in developing the transport and storage infrastructure. So that was very much the thinking, right? Create those conditions upon which the transport and storage can flourish. But of course, the government hasn't completely left their hands off this development, not at all. And they have set a number of conditions upon which they see that the development of CO2 transport infrastructure should take place. And I've listed these conditions. So speed of deployment, so to ensure that things are happening at a timely manner. So that's partly providing the correct subsidies, but also potential involvement of EBN to facilitate the development of storage sites, to highlight which storage sites are the most most suitable and beneficial, and in a coordinated way to ensure that the long-term costs to society are kept as low as possible. and also potentially studies for, the government will support studies for the site characterization of storage sites, for example. Secondly is spatial planning to ensure that CO2 storage, transport and storage infrastructure takes into account the other developments in the North Sea. The North Sea has a lot of potential, but it's also very congested. Offshore wind developments, shipping lanes, fishing, military practice zones, ecological zones. So it's a fine balance to make sure that all the uses and needs of the North Sea. And the government does that through a national coordination program and the program North Sea to ensure that the different uses are kept in balance. Safety is currently the responsibility of the state supervision of mines in the Netherlands. But we also notice that some of the aspects around CCS and CO2 storage are somewhat unclear. One being, say, who's responsible for the long-term stewardship of the CO2 storage sites, and who should conduct the monitoring that's obligatory under the CO2 storage directive during the period where the government is responsible for doing that, because the state supervision of mines is a supervisory body, but not so much an implementation body. So we're thinking about how this long-term stewardship should take place, and again, EBN could play a role there. The prevention of over-subsidization. So we have competition within the SDE, so the CCS projects have to compete with each other, so they can't. They have to be careful with what they're asking for in terms of subsidy. And we also conduct yearly external reviews on transport and storage costs to ensure that what is being suggested should be a transport and storage fee is correct. Third-party access, enforcement of the EU directive that's implied in the Dutch mining law. Again, that's the responsibility of the state supervision of mines. And we also, if for example, additional regulation is necessary to ensure that third-party access ruling is enforced correctly, then that's something that we're still considering. And also finally, stimulating the reuse of infrastructure. And we have a national platform for reuse and decommissioning, again led by EBN, which is really important. Finally, on an international infrastructure development, we have MOUs in place with several countries. And in part of these MOUs, we're exploring transboundary transport and storage needs. And with that, I think I'll hand over now to Michelle.
Thank you, Tom.
Which one? Yes, this one. Thanks, Tom. I think that gave a good overview of our CCS policy in the Netherlands, and I was asked to reflect on this from a more societal perspective. My name is Michelle Prins. I am the program lead for industrial transformation at Natuur en Milieu, which is a Dutch environmental NGO working on climate and biodiversity. Going one back, well, this is good. So obviously we're talking about CCS, but I cannot talk about CCS without painting the broader picture of industrial transformation. So in the Netherlands, industry accounts for almost 30% of our national emissions. And if we want to keep climate change below 1.5, we have to cut emissions deep and fast. And I think this morning, several people already gave a good overview on what needs to happen. And well, this is actually our view of CCS in the broader picture of industrial transformation. And every time I look at this, I think, okay, it's not that complicated. It's just, you know, saving energy, process efficiency, circularity, which is really important to reduce energy demand, electrification, direct and indirect with hydrogen, and where there are no alternatives, CCS. And I also stated here the right deployment of CCS, CCU, and carbon removals. but I think Andrea gave a good picture of how complicated that actually is. Let me see how this, yes. So, as Tom mentioned, CCS has sparked quite a debate in the Netherlands. And I actually think it's not just in the Netherlands where there's a lot of debate on CCS, but actually everywhere. And for civil society organizations, I listed here the main concerns on CCS. This is actually a small part of a big argument map on CCS. And it was funny because I saw that in the background of Andrea's room. She had the whole map, so you can look it up on the internet. It's called the Argumentenkaart of CO₂opslag. But our main concerns are that, well, of course, there are the risks of lock-in. It's an end-of-pipe technology, so there's no phase-out of fossil fuels. It's not a 100% solution because of non-100% capture rate. It needs energy, it's energy intensive, and it could delay or hinder investment in renewable technologies. And also, there's a concern about safety, about ecological impacts. We have, with the portals and the ARRRA project in the Netherlands, there are extensive studies now being asked actually by us on the ecological impacts of CCS in the North Sea. And also related to that, who is responsible for that and liable for that? Not when it happens now, but what happens, who's responsible when there's leakage in 20 years or 50 years or even 100 years, because that is the time span we have to look at for sequestration. So Tom actually told something about the policy, and it was a nice overview on one slide, but it took us almost 2 years to negotiate the policy. So my first advice would be to have a public debate on CCS and take your time for it, because it does takes time. In 2019, we set up the Dutch Climate Agreement. There were 5 sector tables, which industry was one. The other ones were electricity, built environment, agriculture, and transport. And all of the stakeholders, companies, industries, civil society organizations, unions were involved in the negotiations. And as Natuur en Milieu, we were part of the so-called Green Coalition. It wasn't our name, but people called us that. And it was a coalition with other NGOs, Greenpeace, Milieu Defense, the local Natuur en Milieu federaties, but also with other parties like the union FNV, the Young Climate Movement, and the Trade Organization for Sustainable Companies. And we really took the time to discuss our concerns on CCS. And CCS was actually just a part of the climate agreement, but I have to say it was quite a big part of these talks. It was such a big part that for CCS we set up a, you call it a side table, where we did a joint fact-finding on, well, the usefulness and necessity on CCS, the risks of CCS, and, well, how policies should look like. And although it was sometimes a really heated debate, we reached consensus that CCS is needed in order to have fast CO2 reductions, but also the fact that there are lock-in risks was acknowledged by industry and by our government. And I think to have it, well, actually formally acknowledged in, well, a joint fact-finding was really important for NGOs. Because, well, back then one of our concerns was that industry will prolong the use of fossil fuels and CCS for like until 2050 and beyond. But now, also as Tom said, we really see this as a transitional technology and as a bridge technology. So the Dutch government came with this CCS policy framework, where, yes, we need CCS for the short-term reduction, but we also need to address the risks of lock-in. Tom, took a deep dive in the CIF. I think it's a really sound and, actually a good way to address lock-in risks. The study is done every year to see if there are alternatives. And it really gives a good picture on, what the alternatives are and if CCS is really necessary or the only way to go. We also have a cap on the maximum on CCS that is subsidized. And we were also really happy with it because it means that, most of the subsidies actually saved for other technologies than CCS. So we can also scale up green hydrogen, electrification, while also doing CCS. And the horizon, the horizon is a bit far, 2035, but to us, it showed that, yes, it is a bridge technology and we're not going to subsidize it until 2050 and beyond. Of course, from our perspective, this is the result of negotiations. Dus we're happy, but it can always be better. For example, what we really like to have in the climate agreement was a portfolio obligation, which was introduced by Helene de Koning in the Netherlands, which says, okay, you can do CCS, but you are obliged to have you're obliged to also work on other technologies than CCS, and you have to make that clear to the government and to society. And the CEF actually is that in, and the cap is that on a macro level, but we actually also want to see that on a micro level, on company level, and that is actually also a role. If we talk to companies who are expecting a lot of CCS, we always challenge them, okay, but what is your plan if you're going to phase out your fossil fuel? What is your plan beyond CCS? And I think that is really important for NGOs to keep asking. Is the discussion done in the Netherlands with the climate agreement and the policy? Unfortunately, I don't think so. Because we have our projects on their way. We have Portos, we have ARRRA project, which is a really big transport project. And in the Netherlands, the discussion on how to govern these projects is actually growing with the amount of projects we are doing. Tom touched upon it, but how does CCS will be regulated? How will the transport and infrastructure will be regulated? In the Netherlands, we decided, okay, it's a business-to-business business, so we leave it to the market. But it actually means that the ARRRA project, which foresees 20 megaton of CO2 carbon capture and storage, which is an initiative of Shell and Total Energies, it means that we, as the Netherlands, are dependent on them for meeting our climate targets. And 20 megaton in the Netherlands is as much as the industry has to do until 2030. So we as a society, I think we have to have that discussion. Do we want to be dependent on private companies? And it doesn't even matter if it's Shell or Total, but do we want to be dependent on a private company who can say, okay, now it's not feasible for me anymore, so maybe I'll do another business. But yet we still have to store this the CO2 and meet our climate targets. So the way it is actually now in our government policy on infrastructure, well, I have discussions with Tom and his team, and I really hope that we're having these discussions in the coming months, because we are in the beginning of the CCS projects and developments. So now is the time to do the infrastructure and the governance model right. So yeah, no silver bullet. Andrea already said that. We as NGOs often get to blame that we are dismissing options. But I think also from an NGO perspective, CCS is not my popular option. I'm not here to cheer on CCS, but we need to, because our biggest concern is not lock-in, it's not even safety, but our biggest concern are the impacts of climate change. So unfortunately, we need CCS in the short term to mitigate that. But CCS is not the silver bullet, nor are the other ones. So, well, I ask the same to industries and governments to also look at direct electrification, to hydrogen, to energy saving. Fortunately, energy saving has come to light again with the gas crisis, but it was really neglected the past years. And we need all these options to keep 1.5 alive. I thank you.
Thank you, Michelle and Tom. We have 5 minutes left for questions. Are there any questions? 1, 2, 3. Okay, perfect. 4. Let's start with 2 and then take three last questions. Okay, Erwin.
Erwin Cornelis, ECOS. Am I coming through? Are you hear me? Can you hear me? I have a question about the CO2 price. The CO2 price is now very high and is also, well, almost reached 100 euro per ton. And I'm wondering to what extent this is speeding up the process. In the other direction, so if the CO2 price drops within the near future, to what extent will this slow down the process? Thank you.
We will first take another question. Please raise your hands again. Okay, there and there. You can start.
I just wanted to ask for, sorry, Aymeric Raymond, Southpole, for a specification on about the sieve. Probably I'm pronouncing it wrong, but you mentioned, Michelle, before that a study was done every year to verify again whether there were alternative technologies. But how does that work in the sense that a project needs to take a decision for the long term, so for 10 years and decide to invest in infrastructure, and if 1 or 2 years later they lose that subsidy, then suddenly the project business model does not work anymore? Maybe I didn't understand very clearly how it works, so I'd love to have some detail on that.
Thank you. Over there.
Okay, so Reginald Jordan from Holcim, the Belgian part. We have been looking for close to 2 years now for CCS solution for our CO2, and we have been exploring, I believe, all the available options in the North Sea. Something that strikes us, whenever we talk to Dutch projects, we can talk long time, but we have not succeeded so far in getting clear information about timing. So
about what? Excuse me?
Timing.
Timing, yes.
Schedule, which is not the case in other countries, like Norway, not to mention it. And then also recently we read in the news two announcements. One was from ARRRA, but they decided for the Dutch emission to go for a solution in Norway. We also saw an announcement for Neptune Energy. They decided to go for a joint venture in Norway as well. Then comes now the simple question. Is the CCS Dutch solution really open access for foreign emitters?
Okay, so Tom, 2 questions for you. One about the CO2 price and another one about the timing of CCS projects in the Netherlands. Is the North Sea really open access? And this is coming from a speaker from the cement industry.
Yeah, where to start? So the ETS price, I mean, that's the whole point of having the SDE subsidy that covers that gap, which is evaluated on a yearly basis. So if the ETS price stays high, then it's a benefit for the government, for for my ministry, because then we pay less subsidy to the companies, and that money that's saved can be used for other projects. If the ETS drops, then it's a guarantee for the government that the CCS projects will still move forward. But of course, it means that more subsidy has to go to CCS. That's why every year the long-term ETS price is made quite conservative, like around the 50 to 60 euros for this year, rather than taking a very optimistic base price of, say, 90 euros, which could mean that we allocated too little budget for those projects. So the whole point of the SDE is to make sure that the government and the companies have the security that the project can move forward and make the necessary emission reductions, and given the fluctuations in the ETS price. And maybe I can answer really quickly for time purposes that bit about the SDE. There was a question about how the sieve works. So this study, or the sieve is what it's called, it's applied once each year, but it's not for projects that already have subsidy allocated. They are not then again tested against the sieve in the year. So they're tested once, the categories. Once they're allocated subsidy, they have that subsidy in place for 15 years. So maybe to answer one. And in terms of from Holcim, the Belgian gentleman, there's a lot to say about that, but indeed the CO2 storage in the Netherlands is open access. What we have of the CO2 storage, there are some questions about definitions. The drivers for CCS between the Netherlands and Norway cannot be compared with one another. Norway has relatively low national emissions and high storage potential, and the Netherlands also has a high demand for CO2 storage, also has high storage potential, but it's about the speed in which we can develop that. And if we look compared to the Netherlands and Norway, if we take the Porthos project, that's 2.5 megatons, you take the first phase of the ARRRA project, which is I think estimated at 5 megatons, and then you compare that to the developments with the Northern Lights projects, and I think you'll see that the storage under development is actually quite comparable between the countries. It's just that demand for storage in the Netherlands is far higher than in Norway. So the Netherlands has open access. It's a requirement by law. There's just not enough of it under development at this point. We don't have that surplus that Norway is able to generate at this moment in time.
And I think the question about the timeline is also important. We heard it already a few times today. Can you give the people from industry in the room a concrete date where they can start shipping their CO2 to the Netherlands?
As far as I'm aware, the Porthos project has been allocated the storage availability already for some years. In the first year of the SDE round in 2020, where there was less interest for CCS given the ETS price, and that part of the ARRRA project is under development with an estimated development time frame of starting between 2026 and 2027. And I think the reason, I'm sure that the companies have got more exact time frames, but it's the sheer extent of that project, that the pipeline that needs to be developed, the storage sites, how long the storage licenses take to get ready, that is some uncertainty, of course. These are major infrastructure projects with a lot of uncertainties. They have to have the business case ready. It's not possible, I don't think, at this moment in time to give a specific date upon which companies can send their CO2. And then again, it's in a commercial arrangement between the country, what the companies capturing the CO2 are willing to pay, and what the companies need in order to guarantee access to storage sites. And the government at this moment in time, we're not in that part, because at the moment the CO2 storage tariffs are not regulated anywhere in Europe.
Okay, thank you so much, Tom. Michelle, there was also a question for you.
Yeah, I think it was about the sieve. Tom already mentioned it, and I think that was one tricky bit on the sieve that NGOs were a bit worried about, because the study on the sieve is done upfront, and initially they looked at, okay, what alternatives come into play within the next 5 years. And you can debate if that's maybe a bit too short, because if something comes along in year 6, you still have invested in CCS for the coming 10 to 15 years. But what if in year 6 or 7 the alternative is more feasible? Then you have created a lock-in. But I mean, there's no way you can totally mitigate the lock-in risk. So you need to find a balance in that.
Okay, there were more questions. One over there, one over there. Okay, go ahead.
So my name is Theo Middelbrink. I work for Public Matters, and I have a question for Tom. Could you explain a bit more about the conditions for the different allocations in the SDE subsidy scheme? So how are the different allocations determined?
And the next question.
Sophia Schönborn, Industrial Union IGBCE from Germany. Michelle, my question is, since you and the other colleagues from the other NGOs were involved in the process, I think the Netherlands won't face any demonstrations or conflicts when the CCS infrastructure will be built. So on like nature conservation and these topics, is it right?
Okay, let's start with Tom.
Yeah, so about the allocation, so the new system to be introduced in 2023, this is still under development. So I haven't got any further information on the amounts or how the allocation between technologies will work. So I can't really help further. I think in the autumn, these details there was a parliamentary letter just before the summer in which it stated that in the autumn, the information on how this system will work will be released in time for the opening of the round in 2023.
Thank you, Tom. Michelle?
Yes, well, although all the NGOs were involved in the negotiations of the climate agreement, not all NGOs signed the climate agreement. So Greenpeace and Milieudefensie did not. Greenpeace, one of the reasons they didn't sign was that they didn't want any CCS. So the debate is still a bit tricky and I would say a bit vulnerable. Now, with the projects being underway, well, I think their resistance is a bit weakened or soft. They don't oppose it. They don't have any campaigns on against CCS or anything. But of course, but also we as an NGO, we're really on top of what are the ecological impacts and risks of these projects in the North Sea. But we have that North Sea program, which is also with a lot of stakeholders trying to agree on all the issues. So that is a bit the Dutch polder way that, we try to find common ground, actually.
Okay, thank you so much, Tom and Michelle. So we have a well-deserved coffee break of 25 minutes right now. We will be back in the room at 3:35 p.m. Enjoy. Okay, everybody, is there still some energy for the last part of our conference? I hope so, because we have many speakers. We will start with the role of ports as hydrogen and circular economy hubs. And the speakers for this are Tycho van Houwaert, who is Policy Officer on Industry and Circular Economy at Bon Beter Leefmilieu. And Jakob Petuchnik, I hope I pronounced it correctly, and he's the Policy Manager of Zero Carbon Fuels of Clean Air Task Force. Tycho and Jakob, you can come already to sit in front, and then we can start with your presentations. Don't run away after the conference, because we have some Belgian beers and wine for you and some snacks to celebrate this lovely gathering. Enjoy.
Hi everyone. Let's talk about circular economy. I think we heard a lot about CCU, CCS, other technologies, but I think it's also a priority in industrial transition to talk about circular economy. I will talk about it in general way and then give some policy recommendations as well, and also dive into the role of ports, of course. Yeah, let's start with the problem definition just in general way. I think there is insufficient attention to the growing material footprint. Today we use like 100 gigatons a year of materials in construction, plastics, and so on. And according to the OECD, this will rise to 167 million tons in 2060. So this is a trend we need to stop because it has a lot of environmental impact and so on. And that's why material and energy consumption is a very important topic also in this day, as in the study day. And on the right graph, you see the European material footprint, and what we see is that there is not much difference between 2010 and 2019. This means that it's very hard to reduce our material consumption, but it is an essential strategy. When looking at greenhouse gas emissions, I think when we look at materials, a lot of our emissions are material related. For Germany, for example, it's about 40 to 45%, and even in Flanders, it's even more. It's about like 60% of the emissions are material related. So if we can impact the greenhouse gas emissions in materials, then we have already a good opportunity to keep the 1.5 degrees dream alive. And I think this is a graph on the right that we see each other, that we already saw this morning from Thomas Waynes, and it's showing that the end-of-life emissions are very important, and that's why we also need to look into this. When it comes to plastic, a lot of emissions come free, so are released during waste incineration. And if you only focuses on the production phase and technology, then we only target the CO2 emissions in the process. And that's why circular economy is so important. It is about value chain thinking, rethinking, and if you, for example, map your Scope 3 emissions, then you could see the whole value chain, upstream, downstream, and then you could tackle all these emissions, even the emissions at the end of life. So circular economy is a major strategy for the industry, and because it can accelerate the achievement of climate, energy, and environmental goals. When looking at all the projections, energy consumption will rise, and the problem is that technically and economically and politically feasible? And my answer would be that's not the case. For example, on the left, we see a study work from Can Europe that shows that we can halve the emissions by using circular economy as a main strategy for the industry. And it's true, Europe is poor in raw materials. So what we should do for the competitiveness for the European energy-intensive industry, it is really to focus on the materials that are at European land. Due to the energy price crisis today, we also had after Corona, we had a lot of logistical problems with virgin materials. We had troubles with the Rhine this summer with droughts, and so our competitiveness is under pressure. So I think it's very important to also have this strategic autonomy at the European mainland and the circular economy, where we can keep our materials in our country itself. And then a last one is that circular economy is also a key driver for digitalization and new business models, because if we want to create a lot of industrial new value chains, then we will have advanced digital creation to, for example, analyze the material flows and so on. So those are three arguments to try for a circular economy. I was already saying that there's a lot of potential for circular economy in Western Europe. It could So to work on the climate emissions, to work on climate change, I think it's a very important strategy. Study work for material economics, for example, show that we can halve the emissions for the basic materials. That means steel, plastics, and also concrete and aluminium, for example. And if you look at the different basic materials, then there are a lot of strategies to focus on. It's about material recirculation, it's about material efficiency, it's about new business models, and for every basic material, we can work on those. So the potential is big, and then, of course, we have the technologies and CCS and hydrogen, of course, and that come later. But circular economy is a major strategy for Europe. It is also the same for energy. Thomas Waynes was already telling that in every scenario the energy consumption will rise, but when looking at the circular economy scenario, this is the least energy intensive. And my question is always, okay, where does the energy will come from in the future? And this is a major bottleneck because we don't have enough energy to change every process by a new climate neutral process. And we have not that amount of renewable energy, of course, available in the countries. And then we're looking at import like we do right now. So the energy could be a major bottleneck for the transition, and that's why circular economy is an answer to that. European Union or the European Commission is today already working on circular economy. Of course they are, but these are 4 arguments that we see in policy files. For example, in the steel and in the cement sector, we can downcycle, and now I think the focus should be that we don't downcycle anymore. It has a good reason. It had a good reason because we want to develop markets, but now we should make from a plastic PET bottle another plastic bottle. And mainly the policy targets are focusing on the quantity. It's about targets of recycling, of collecting, but now we should focusing on the quality, that we could recycling as much as possible, for example, the steel scrap. The third point is the statistics. We see in the European Commission that every member state should report on the amount of recycled PET or plastics in general, but we see that these are incomplete or unreliable. They tell us it's about we are recycling 50% of all the bottles, but in fact it's only to 50%. So if policymakers want to create policy, then it's important that we have the real statistics, of course, to improve the policy. And then a 4th point is that material efficiency is largely forgotten. Which country has targets on material consumption, and how can we improve our products that way that they are as efficient as possible? So the strategies, that's not rocket science, of course, it's material recirculation. So that's the use of secondary materials in steel, in cement, the plastics. And this means that you will end with lower emissions per tons of materials. The second one is material efficiency. So you should design products as efficient as possible. And this means that you lower the materials per unit of final product. And then we have new business models, and yeah, the meaning of that is that we try to have products with the same economical value when it comes to service to consumers. So this doesn't mean economic loss. This means we're gonna try to do it with less material, but with the same economical value. And this will lower the total level of products per unit of service. And a big example is, of course, car sharing or laundry sharing with your apartments. And that are 3 strategies that we can use to stimulate the circular economy. But one major thing is also that we cannot forget the demand side. And this means that we need to create markets, of course, for those products. We need to create policy that we can stimulate, for example, car sharing and so on. And study work for material economics point out that there is a lot of potential to do. And this is something I want to say, that a circular economy is not only about recirculation, closed loop, and so on. It's also about a societal perspective. And this will definitely come up soon. So, kind of policy instruments that are now discussed, for example, at the European Commission. We can start with the European Action Plan of Circular Economy, and I think now there are some directives or regulation that come into place. For example, the Eco-Design for Sustainable Product Initiative. And I think this is important that we, for the basic industry, it is important because this regulation is targeting intermediate products like steel and cement and aluminium. Cement, no. Yeah, it's important that that this regulation is as ambitious as possible, of course, that there are targets about material consumption as well. The main new thing is the product passport for every product, for example, but for NGOs, there should be like a target in it for consumption. And then the emission trading system, with the auction revenues of the allocations or the allowances, we see that a lot of money goes to the innovation funds, but what we see is that they're mainly targeting CCS projects and hydrogen projects, and not circular economy right now. So this could be a policy recommendation to also look at this circular economy thing. But here, a main message, of course, is that not only the European Commission needs to play a role in it. I think the member states themselves are a key driver for this transition. Because, for example, national policy is very helpful to choose strategic sectors. We were talking about ports. Every port has its own characteristics. For example, in the Antwerp cluster, we have chemicals. So if the national policy makers from Belgium see, okay, we have a big chemical sector where we need to think about it in the transition, then you could focus on, for example, plastic recycling, chemical recycling. So national policy can really stimulate the way of this transition could be. In a lot of countries, we now have a target on material footprint. For example, in Flanders, we have a material footprint reduction of 30% by 2030. But there the question is, how can we take this with us towards the industrial transition? What does it mean for industry? Does it mean that we have to consume 30% less? So there are some questions. For example, in Sweden, they now try to they also want to take the emissions from imported goods as well. So that's also stimulating this value chain thinking. And then a last one is procurement policy. I think a lot of transactions in the world are going between organizations, between PPAs, contracts between two parties. So it's not only the market that has a big role, but also the procurement from authorities and organizations. And the PPA thing will be key in this transition. And when it comes to circular economy, we can focus on, for example, criteria for stimulation of circular building materials. We can work with minimum recycled content, and so on. And then I think it is also important to talk about the economics itself and about the employment, because what we see in a lot of study work from, for example, the Ellen MacArthur Foundation, we see that the circular economy will gain a lot of jobs. For example, on the left side, I think we see that the Flemish economy improved in the last decade, but the circular economy, when only looking at circular economy, we see that was a multiply with 3 times. So the circular economy will, of course, create jobs. And what we can say also, and I think that's very important, and it will come up in the debate with the trade unions, of course, is that employees needs to be concerned when it comes to this transition. I'm talking about societal transition, and this means that employees, of course, need to be there on the table when it comes to, for example, discussing the climate roadmaps and so on. And I think we will also need the employees because of the job skill and education system that's going to be completely different when we're talking about a real circular economy. I'm just going to end with some policy recommendations. I was talking at the beginning of we need policy targets, and I think a good one should be a reduction target on consumption or virgin resource use. Waste prevent targets are very important. We have the Waste Framework Directive coming up, and the prevention is so important. We should ban exports of waste, and that we can keep our plastics and steel scrap here. Creation of markets is very important. I was talking about defining minimum recycled content. We have, of course, the major circular economy policy files at the European Commission and the Sustainable Product Initiative, for example. Waste incineration should be put in the ETS, and that's why we can keep our chemicals out of the waste incineration, but have a real incentive to recycle them or to use them as a new feedstock for the chemical industry. Collaboration is very necessary in the value chain, and this value chain thinking needs to grow a lot of attention. And yeah, one of the things we're now looking at is the EPR, so the Extended Product Responsibility, which is an instrument and an important instrument to avoid a lot of waste or to manage waste. But this instrument should be evolving towards an instrument where we can also stimulate eco-design, waste prevention as well. So this EPR instrument will be very important in the coming of years. When it comes to the financial part, I saw on the Dutch presentation that there was like a technology or a scaling up subsidy, and I think this is something that is very necessary. And when it comes to the ARRRA cluster, that we can scale up the circular economy activities. And I was talking about the innovation fund from the ETS, so we will need to have a minimum share for the circular economy. And when it comes to the role of ports, and it's also, we can also apply this towards the story from Jacob when it comes to hydrogen. Ports are very important because of their logistical strengths. Just a brief exercise, so Antwerp has a lot of chemical production, Rotterdam has refineries and biomass, and Germany has metals and steel. And so everybody has his strengths, and now working together. We saw Thomas Waynes this morning with every detail of what should port authorities do, what should national authorities do, what should the European Commission do. But of course, every port has its strengths, and we could connect those strengths because we will need cross-border infrastructure and so on. Upscaling activities, I think Thomas Waynes was telling about this, that the ports can help with concessions, with permit applications and so on, test zones for startups, and I think there are some projects going on in Antwerp and Rotterdam. And port authorities can also play a major role as a matchmaker because they have all the knowledge, they can exchange between industrial sectors. This could be helping exchanging waste streams and so on. And of course, the port authorities can be a matchmaker when it comes to the development of business cases for industry as well. So now I'm thinking I gave the word to Jacob.
Yeah, thank you, Tisho, and hi, hello everyone. Also from my side, I hope you still have the power to sit through my presentation, and I will try to keep it short and sweet. So I'm going to talk a bit about hydrogen economics, transport routes to Europe for hydrogen, and so the regulatory framework for certifying hydrogen that is needed to move and secure scalable hydrogen volumes. So today the EU consumes about 8 to 9 million tons of hydrogen, which is equivalent to roughly 280 to 300 terawatt hours, and which represents about 10% of the total global hydrogen demand. So for 2050, all of the studies that we looked into, including a study that we commissioned, indicate that the European Union could see a hydrogen demand well above 60 million tons, or well above 2,000 terawatt hours, which marks a more than sevenfold increase. So funny enough, the European Commission's impact assessment is actually the most conservative scenario projected here. So in a nutshell, the key takeaway from this slide is that it requires both. So a scalable path of domestic hydrogen production in the EU and importing large volumes of hydrogen to satisfy this massive projected hydrogen needs. So today, oil refining is the largest consumer of hydrogen in the EU, and this is most likely to remain so in the short and medium term. And other industry sectors where drive demand heavily are ammonia production or methanol production, and we will also see a substantial increase in hydrogen consumption for the direct reduced iron process for steel making, but also for certain hard to electrify transport segments such as long-haul trucking, for example. So the status quo is that so most of the hydrogen that is consumed in Europe today is produced locally as captive hydrogen, which means that it is hydrogen that is produced by the consumer for internal consumption, and roughly 5% is byproduct hydrogen, so that is hydrogen produced as a byproduct from industrial processes. So all of that hydrogen production comes from steam methane reforming, and or most of it, and only a very small fraction comes from water electrolysis. So that's why the EU plans to produce 10 million tons of renewable hydrogen by 2030, according to its Repower EU plan. And so these volumes, they require almost half of the total EU power generation of 2019, and also utilization rates that can actually only be achieved if a large portion of the electrolyzers is connected to the grid. And this would then raise questions about the carbon neutrality of the hydrogen produced, so if the grid is not fully decarbonized. And also these 10 million tons would cover only the current EU industrial sector hydrogen demand. So, which is why the Repower EU plan also includes 10 million tons of renewable hydrogen from imports by 2030. So, and the key takeaway here is that Europe sort of recognized its need to import significant volumes of hydrogen to satisfy its demand for the foreseeable future. So by 2030, the potential demand for hydrogen will be high enough to initiate a substantial international hydrogen trade between European countries and also countries outside of Europe. So geographically, a northern hydrogen cluster around the Netherlands and northwest Germany will be very significant. So we already touched upon that quite extensively today, so I won't go into further detail with that. But what we will see is more of these simultaneous development of demand, production, and infrastructure projects for decarbonized hydrogen in the EU. That's why this hydrogen value chain graphic is shown here. So, and this will require sort of common approaches and common rules for the entire hydrogen value chain. So, of the current global projects for which the offtake details and the intended destinations are known, about 8 million tons of hydrogen per year are marked for export to Europe. So on a bilateral basis, for example, Germany has signed numerous bilateral agreements, strategic partnerships, alliances, joint undertakings, and just to name a few, the most recent one is the Canada-Germany Hydrogen Alliance, which foresees hydrogen imports to Germany from 2025 onwards. And then there's also a joint undertaking or a joint declaration of intent with Qatar to which includes the development of renewable or the development of framework conditions for green and blue hydrogen trade. And then there's also an agreement between the UAE, specifically ADNOC, which is the Abu Dhabi National Oil Company, and German companies to build a renewable hydrogen supply chain. So the hydrogen will be produced from renewables in the Emirates and then shipped to Wilhelmshaven in Germany via liquid organic hydrogen carriers. Yeah, also the Netherlands have signed numerous deals and hydrogen alliances to import hydrogen, and specifically the port of Rotterdam sort of tries to or aspires to become the prime logistical hub for the European hydrogen economy, and also to produce hydrogen for its own industries. So the first hydrogen tankers are expected to arrive in the port of Rotterdam in 2025. And for example, there's the H2 Vision project for the production of blue hydrogen, which should become operational by the end of 2026. So originally, a final investment decision was scheduled for 2021, but that has been postponed a bit. So yeah, just to sort of picture a few of these agreements and developments. So hydrogen makes renewable energy transport more cost efficient, and over long terms or long distances and in larger quantities. So versus, for example, comparing it to electricity as a transport vector. So, but it also needs to be further processed to make it suitable for transport, and so either compressed or converted into other molecules with a higher energy density. So some of the most attractive options for shipping hydrogen, and we have already heard that today, are via ammonia or via liquefied hydrogen or liquid organic hydrogen carriers, so that these are oil derivatives that react with the hydrogen. So we commissioned a study to look into the landed cost of hydrogen carriers into the port of Rotterdam. So this study examined the cost of low-carbon hydrogen imports into Rotterdam from 5 different maritime exporting locations. So Norway, the US Gulf of Mexico, Argentina, Qatar, and Saudi Arabia. So also, you see Russia is on this map too. So this study was commissioned before the start of the war, and subsequently we took Russia out and focused on these 5 exporting locations that I just mentioned. So these locations were chosen because of their significant gas reserves and also their production capacity. And for the hydrogen value chains, they are based on high carbon capture rates, so well above 90%, which can be achieved via thermal reforming. So the transport cost of hydrogen is mainly dependent on the size of the project and the transporting distance. So especially for transporting hydrogen over longer distances via pipeline, this is critical because the costs for transporting hydrogen via pipeline are direct proportional to the distance. So while for shipping hydrogen, as a rule of thumb, you can assume that 70, so almost 90% of the total cost is associated with terminals, so export and import terminals. So overall, ammonia is the most attractive option for the widest range of size and distance combination. And this is mainly because of low transport costs. So the highest energy or economic penalty, so to speak, for this pathway is the conversion from ammonia back to hydrogen, so the cracking process, which can lead to up to 30% of energy losses. So the key takeaway here is that from our analysis, we found that importing hydrogen from Saudi Arabia using seaborne transport gives the lowest landed costs across all 3 carriers and across all years, so 2030, 2040, and 2050. And this is mainly because of a combination of several factors. So shipping distance, natural gas feedstock prices, production costs, and export terminal construction costs. So it's just a quick comparison with the landed costs for hydrogen imports from the US. And we also looked at transport routes via pipeline from Norway and Russia and Algeria. And again, this study was commissioned before the Russia-Ukrainian war, so we left Russia out and just focused on Norway and Algeria. And so I won't dive into the details of gas infrastructure build-out and getting gas transmission networks hydrogen ready and the European hydrogen backbone, as we have already heard about that quite extensively today. But I want to throw in just one word about the pipeline import economics that we looked at. So just in a nutshell, pipeline imports from Norway have the lowest landed costs for 250 kilotons of hydrogen per year, while Algeria has lower costs for larger sizes across the value chain, which is mainly influenced by a quite competitive and low natural gas price in Algeria compared to Norway. And similar to Algeria and Norway, a lot of these Middle Eastern countries. So there's no real liberalized gas market there. So there's a lot of state subsidies, and so this is why these countries are specifically very competitive in terms of gas feedstock prices. So here's a brief summary of the key takeaways, which I won't go over in detail, so that I can briefly touch on the regulatory and policy framework discussion, as I indicated at the beginning of my presentation. So I mean, the key takeaway here really is that almost 40% of the announced capacity for the EU 10 million tons target is probably going to be the largest portion of the capacity is probably going to be commissioned in the Netherlands and Germany. And so, but most of these projects are actually announced projects, so they haven't reached FID yet, so there's a lack of final investment decision. And this is why it really needs these additional policy mechanisms and instruments, such as carbon contracts for difference, which we also already talked about today quite extensively. And yeah, so these instruments are needed to rapidly ramp up market production and to sort of also de-risk technology investments in low-carbon hydrogen production. So even though the EU ETS reached an all-time high in February this year, so almost 100 euros per ton of CO2, but still this price isn't really high enough to sort of support pre-commercial technologies or even some of the more mature technologies for low-carbon hydrogen production and overall decarbonisation technologies. So, I mean, ideally, so for example, for Germany, for their CCFD version, which is called the Klimaschutzverträge, and so they're currently in there's this public consultation phase going on. So, but ideally, what we would like to see is to cover CCS solutions in combination with low carbon hydrogen's supply. So, yeah, and just, sure. So that's good because that's my last slide. So from a certification and standardization standpoint, ideally what we would like to see is more of an EU-wide alignment. So most of the existing hydrogen certification schemes are voluntary, and they are not really fit for purpose to have this full emission accounting scope. So the emissions assessment are limited either to the hydrogen production facility, or they only include limited downstream emissions, or for example, when we looked at Germany, they have developed a certification mechanism, but this mechanism only targets renewable hydrogen, but Germany already has signed a couple of memoranda of understanding to import other forms of hydrogen. So, then there's the certify high hydrogen project, which is sort of the European Commission's initiative to include, to sort of the connecting tissue for hydrogen certification across Europe, but that also only covers direct emissions from the hydrogen production facility itself. So, and this is my last sentence. So since the gas package has this technology inclusive and sort of technology optionality approach, it would also make sense for the certification schemes to include renewable and low carbon hydrogen. And so for us, ideally what we would like to see is more of the discussion to shift away from this pure color coding, so green, blue, pink, or whatever, and more towards volumes, scalability, and actually full life cycle emissions analysis methodology. Thank you.
Are there any questions for Tycho or Jakob? Okay. I see 3 hands. We will take the questions together. You can start.
Hi, thank you very much for this very interesting presentation on hydrogen. I had a very quick question on your slide comparing Norway and Algeria, and it's just out of pure curiosity. You didn't mention the difference between the advantage, is it on blue or low carbon or renewable hydrogen? Because on the numbers, I didn't see a vast difference. So I would expect Algeria, of course, to have a big advantage on renewable. But what about low carbon?
Transport options or the carbon options, so that's only low carbon hydrogen, and we're sort of working now on a follow-up to compare that the cost for renewable hydrogen transport routes. The reason why we solely focused on low carbon hydrogen was more of a mature technology, it's easier to scale, and but certainly now with gas price development and everything, renewable is actually worse, renewable hydrogen is actually worse and more cost competitive.
And maybe to add to your comment, and following up with the recommendations on the regulatory processes in the European Union, they are slightly more advanced on renewable, on regulating renewable RFNBOs than they are on blue hydrogen. But that's something else to talk about next time.
Okay, thank you. For the speakers, please use your microphone when you're answering. That's for the recording of today. There were 2 more questions. I will take them together. Or 3, even 3. Yeah, you can start.
Annemette Jorgensen from Carbon Collectors. It's a bit following on the other question. Clearly your studies have been made before the Russian war, and I was wondering, how do you see the development of especially this huge import dependency on hydrogen? How do you see that development happening now with the new concerns about energy security and dependency on countries that are not necessarily very stable? Perhaps they are, I don't know, but and also may have issues with actually providing their own people with electricity that is green.
Okay, next question.
Yeah, I got 2 questions.
Please introduce yourself and your organization.
Sorry, Sophia Schönborn from the Industrial Union IGBCE. My first question is to you about the instrument of stopping exports and also imports for waste. I think it's really a strong instrument, really interesting, but the first thing that comes in mind for me is in North Rhine-Westphalia and also in Germany, we do the district heating on waste, so it would be a really problem now. Just a small question. And the other question is for you, Magnolia. Did I get it right that in Rotterdam the import capacity for LNG is only starting in 25? Was it right? Did I get it right? Thank you.
And then the last question.
Erwin Cornelis, ECOS. I welcome very much your call for having solid standards on hydrogen and especially renewable hydrogen. And I was wondering whether the delegated act, which is very much discussed whether that is providing, in your point of view, a sufficient framework for specifying the renewable nature of hydrogen, as it's not only for the EU but also for hydrogen that will be important for the EU. Thank you very much.
Okay, Jacob, we will start with you. 3 questions.
So for the first question, so it was about hydrogen corridors and hydrogen routes. So the European Commission mapped out several of these corridors. So one being the North African Italy corridor, then there's the southeastern corridor, which is connected to Ukraine. And so, of course, given the current geopolitical situation, everything, I think what we will see is in the mid to longer term future is that, for example, the North African Italy hydrogen corridor, that this will be sort of the main focus, and less the Southeast European hydrogen corridor, where the Commission was counting on renewable hydrogen volumes from Ukraine. And given the situation that this is so volatile there, I think it will more shift towards this North African corridor. And so that's what I sort of what my take would be on that, and I hope that covers sort of your question. For the other question, which was about the Port of Rotterdam and 2025. So in 2025, renewable hydrogen volumes are expected to land in the Port of Rotterdam, just renewable. And for 2026, so there's the internally ramp up of blue hydrogen production to cover its industries there. And so, but it's really going to be a bit of a mix. So there's going to be green and blue molecules coming into the port. And so that then again ties back to this whole certification and standardization discussion, where when you have these import terminals and volumes get mixed and molecules get mixed, you sort of need more alignment, because then you can't differentiate between them anymore. And so by 2025 that's renewable, and 2026 we see this low carbon blue hydrogen, and overall by 2030 it's expected roughly 4 million tons or so, and then by 2050, if I'm correct, it's already up to 20 million tons of total hydrogen volumes coming into Rotterdam. And for 2030, so it's 4 million tons of imports and around 0.6 million tons of hydrogen directly produced there at the wider area of the port. And so for the third question, which is about the Delegated Act, so if it's sufficient or not, I think it's lacking quite a lot. So first of all, it's the whole process needs to happen a lot faster. So because these hydrogen agreement and these hydrogen volumes will come into Europe, so this is a market reality that is happening, and so there's really no room to delay negotiations and sort of. So we would need to have this sort of comprehensive framework in place before these imports are going to happen. And I feel like it is also lacking because there is no real clear definitions in there, at least from my perspective, and also this full life cycle emission analysis that is also sort of this methodology, which is also not fully mapped out yet, and this would be super crucial and super important. Again, sort of to have this EU-wide aligned approach, and so I feel like there's enough work to be done with the gas package and the Delegated Act and everything, and there's no time to be wasted.
Okay, thank you, Jacob. Tycho, the last question was for you.
When I was talking about ban on waste exports, it was more in a general way, like we cannot import our waste material outside of Europe, and I think I was referring to the waste shipment regulation, and I'm hearing about the steel industry, for example, that they want also a strong waste shipment regulation to have as many as scrap available at the European market to produce, for example, new steel out of the electrical arc furnaces. But I think when you question about district heating, for example, I think that's a good question about how to look at, for example, the whole value chain. And in our opinion, there will be some waste incinerations left in Europe, of course, even in every country. And you should already think about where to put them or which kind of waste incinerations should be there in the future, because then you could also couple it towards district heating. Otherwise, if you couple already now district heating towards waste incinerations, then this could also be a fossil lock-in, of course, but a lock-in for the waste incineration itself. So that's a good question when looking at a value chain thinking.
Okay, thank you so much, Tycho and Jacob. Then we are now ready for our final panel discussion. I would like to invite on the stage Benjamin Denis, Senior Policy Advisor at Industrial, Bas van Weegberg, Executive Board Member of the Dutch union FNV, Wim Kareel, Advisor of ABVV Metal, and Sophia Schoenborn from EGBCE, the union in Germany, North Rhine-Westphalia. And then, of course, our moderator, Jeroen Fontaine, Project Manager, Circular Economy and Industry at Bon Beter Leefmilieu.
Good afternoon. While we were preparing for this event, it was quickly clear that it would not be complete without a session about just transition, and that's exactly what we'll be talking about in the next 40 minutes or something like that. Before the more informal part of the conference, the drinks, and I know you are looking forward to that, as I am. My name is Jeroen Fontaine of Bon Beter Leefmilieu. We are a Flemish environmental organization and co-organizer of this event. During the past 1.5 years, I have been working on a project sponsored by ESF, which deal exactly with this topic, just transition. We had a good collaboration with Industrial Europe, with Reset Vlaanderen, another organization, and with Flemish trade unions. Together, we studied a bit what are the workers' interests in the transition, what can we do to build the support, to have a better support for the transition. And also we learned a lot about sector-specific challenges in the chemical and the metal sector. Now, before I give the floor to the speakers, I just wanted to give a starter. It is obviously quite obvious and clear that we will need a strong support for the transition from all stakeholders, amongst them also the workers, because it will have a huge impact on their life, I think, on their jobs. And also we need workers, of course, because a skilled workforce is an important precondition for the transition if you want it to succeed. So the question, and we will talk about that, is how can we avoid forgetting the workers in the course of the industrial transition? And Laureen has already introduced the speakers for you. We will have, in fact, 3 questions which I will ask to the different speakers, and afterwards there will be room for questions, so you can spare them for the last, for the end. The first question I want to ask to the speaker is, how broad is the support already right now? And I start with my own country, Belgium, with Wim Kareel of ABVV Metal, responsible for the metal sector. In your experience, is the transition already top of mind for many workers, and is it in a good or a bad sense?
Okay, so to answer that question, I think it's important to make a distinction between the workers on the one hand and our representatives on the other hand. Because it's a question I ask myself often to our representatives. Do the workers, are they busy with the transition to more climate-friendly companies and so on? And they mostly, not always, you have to be difficult to speak in general terms, but they mostly tell me our workers at the factories are not really occupied with this transition. And I think that that is a right answer, because as of this day, they are not fully impacted by the transition in the companies. The way they work has not changed very much the past years. It will change in the coming years, but it has not changed this much as of this moment. So they are not really occupied with it. But of course, when you look at the climate transition in society, it's another story. You hear they are occupied with things like how can I pay for an electric car, for example? How will I invest in energy to become climate friendly in my house, and so on? So these of course are very important questions. They are occupied this day, but when it is related to the workforce, it is much less the case. So when we look at our representatives, on the other hand, it's another story, because they already hear about the plans of the enterprise to change. They hear about the investments the company is planning to make, and they ask some questions. And the way they look at the transition depends on the company, because if they work in a company which is going to invest a lot of money to become climate friendly, to become more sustainable, they feel, okay, this is a good thing. Our company is investing in the future. It will be a good thing for our employment. It will be good for our company in the long term. So they have a good attitude when it comes to that. And of course, they have questions. I will give an example later. They have questions. What about the skills the workers will need? How will the job change for our workers, and so on. So they have some questions about that. On the other hand, you also have companies which do not have plans to adapt. And there our representatives and the companies are much, they look at it at less a good thing, because they are a bit afraid, and they ask questions like, will my company still exist in the coming years if we do not invest now, and so on. What we hear also a lot is some questions about, okay, our company in the EU is forced to change by EU legislation and so on. Will it affect our production, our competitiveness compared to other countries outside the EU? So they ask questions about that also. Will it affect us? Will we become worse or better if we go the road to a more climate-friendly production? So that is a bit how our representatives look at this.
Okay, thank you. Then over to Germany, to Sophia of the German union IGBCE in the energy and chemical sector. How is the situation in Germany? Are companies dealing with the climate issue? In which way? And how do you see the role of workers in general in it, and trade unions?
Yeah, thank you. I think I would go with Wim, because it's a little bit the same when you look at the differentiation between the representatives, and like we are a big union, we have many knowledge in transforming and transformation, like coal phasing out, and also like getting together, losing industries, and so we know this, and there's the workers in our sectors. It's not only chemical industry, also mining and glass, so paper and rubber. So these are small industries, and they didn't get much in touch with transformation yet. It's the other way around, like mining and chemicals. So they know it, and I would go with Wim. They see the political talks and what we do and how we push also the politicians to get the transformation done, to get the renewables roll out really. And yeah, that's really another thing where you work. And the other thing is, when I go now into a company and talk about transformation, I think they will look at me and say, well, now we have other problems. So that's really, for us, a problem we are facing right now, the big energy crisis. We will push for the transformation. We won't stop it. It's not done, because for us, it's a big modernization program for our industries. But now we are facing really problems like, will some of them stop the production? So yeah, we really are in a difficult situation right now.
The climate issue is never a first priority. That's what I encountered also in the.
Yeah, but when we had a new coalition in Germany starting last year, it really was, or it still is. But now we had a rise up, and everybody wanted to get this done and want to get this on track. And the war started, and everybody was getting unsure how it will all develop. And now we are facing problems because in our industries we really need gas. And we also use gas, not just for energy, but also in the chemical industry. It is used in other ways. So yeah, they are facing big problems. But yeah, they wanted to invest in big new production, and now we will see what will happen.
Then over to the Netherlands, to Bas van Wigberg of FNV. Mark Alexander already mentioned earlier today the example of Tata Steel, the big steel company in IJmuiden, where there was a proactive role, if I understand it well, in the decision of the company. Maybe you can explain me a little bit more about that and tell us if this is representative for the Netherlands or not.
Yeah, so Tata Steel is the steel plant in IJmuiden with about 9,000 employees, of which 6,000 are union members. So it means we have a strong voice in what happens in the company. And our members strongly felt that if the company did not invest in clean technologies, their jobs would be on the line. Maybe not next week, but most certainly in the coming 10 years. So together with environmental organizations, scientists, they devised a plan to speed up the transition to making decarbonized steel, or decarbonized process of steel making. So the company at first had a plan which relied heavily on CCS, and now switched to hydrogen. This is quite unique because this is one of the most primary examples, I think, in Europe where workers, trade union members are engaging in proactive industrial planning. Most of the times we come in action when we feel that our jobs are on the line in the short term, because and we have every right to do that. But if we look forward to the long term, then I think we can achieve a lot more. In this case, the company changed their plans, are now in serious talks with the government on how to set up the infrastructure around Tata Steel. Those are the maatwerkafspraken or the tailor-made agreements, which were already mentioned today. So yeah, but is it representative for every union member? No, of course not. I think the picture painted by Wim and Sophia is the same for the Netherlands. But if workers feel the implications of this transition, then they will come in action. We saw that also in the closing of coal plants, the Hemwegcentrale in Amsterdam. We had to fight for a few years to get a coal fund over there to make sure the workers had the support to make a next step in life and had the financial support to do that. And now we were in talks to do the same thing for the Rotterdam coal plant, but the plant is still producing while the plans were to stop this year. So the workers have longer insecurity, and that's a topic for the coming years because we already know all the coal plants have to close in 2030. So we propose a national coal fund to ensure that no one is left behind, based on the model which we came up with in the Hemweg, where there was also a board with trade unions in it to make sure that everybody can make that step into the future.
Okay, thanks. And over to Benjamin Denis of Industrial Europe. I think Industrial is the largest confederation of trade unions in Europe, if I'm not wrong. Does Industrial support the transition? And after all what you've heard today in the conference, what are your major concerns?
So we are a federation, a sectoral federation of trade unions. So we represent workers from the industries, different kind of industries, extractive industries, energy industries, manufacturing industries, including energy-intensive industries, automotive, shipbuilding, and so on and so forth. And formally speaking, we represent 180 national trade unions coming from 40 European countries. So IGBCE is among our largest members. ABV Metal is also a quite active member, and we have also members among FNV in the industrial sectors. I will try to answer your question. I think that so far it's fair to say that the debate among the trade union movement is not if or whether we need to decarbonize. The key question is how. It's absolutely obvious for everybody a bit serious in our movement that climate change is there. Climate science is absolutely crystal clear. We need to decarbonize, and we need to decarbonize deep and quick. It's climate science. It's also absolutely clear and obvious that there are different ways, there are different pathways, different recipes to reach that objective. And the one we have been arguing for many years now is what we call a just transition. I can enter into more details later in the discussion, but it's obviously based on forward-looking sustainable industrial policy, a series of active labor market instruments to secure labor transition for the workforce, workers' participation, social dialogue, industrial relations, and a social safety net with strong social protection system. And unfortunately, in the current context, we have to be fair again and acknowledge that what is at stake for the moment is less how to decarbonize the economy. It's how to ensure that the EU industry will survive in the coming years. Because in the current geopolitical context and with the deep energy crisis we are in for some months now, we hear here and there that the issue is not that much what kind of new technology are we going to roll out in the coming months, what kind of investment plans. We hear a lot about curtailments, site closures, possible delocalization, and so on and so forth. Fortunately, there are still sometimes, from time to time, good news in terms of investment in new low-carbon industrial facilities. But I'm afraid that if the right policy answer is not implemented quickly at EU level, we will have more and more to deal within the trade union movement with those that are or that see themselves as the possible losers of the transition. And so those who will not immediately be extremely enthusiastic about the decarbonization process, but those that see climate policies and climate instruments as a threat rather than an opportunity.
I completely agree with you, but on the other hand, you may say also that the fossil energy is now the problem because of the high prices. So perhaps can we combine?
It's absolutely obvious that we have to struggle with a commodity issue, and that EU is at the same time using a lot of fossil fuels, and the EU doesn't produce enough fossil fuels, so has to import it massively. So it creates a situation of dependency. So if the engine of your prosperity, the engine of your economic growth is based on something that you do not produce and that you have to import, you are vulnerable. And this is the situation we have to cope with. But we have to make a distinction between the short-term measures that are needed to protect the industry and the longer-term measures that are needed to break that situation of dependence. We know by experience, and I'm coming from a region which has been hardly hit by disindustrialization, that once energy-intensive industries are gone, they do not come back most of the time. So step one, protect our industrial basis. This is a key asset also in terms of jobs, 8 million of jobs in Europe, key asset in terms of strategic autonomy. And step two, invest to break the kind of dependence I just described.
Okay, then we go over to the second part of the discussion. We want to achieve climate neutrality and in time to achieve the 1.5 target, which climate science is clear about. And what do you need as trade unions in the course of the transitions from policymakers and from companies? What do you expect them to do in the coming years? Maybe we can start with you, Benjamin.
So I will maybe focus mainly on what we have been saying in the EU level, notably in the context of the debate about the Fit for 55 package. I will not repeat what has been said about the need to have also a holistic view in terms of what kind of industrial strategy, industrial policy we need. We have been telling for years that for us it's not only about CO2 price, it's not only about EUA price on ETS, it's about creating all the conditions that are needed to make a low carbon industry possible and flourishing in Europe. And we are not there yet. Then we have also a series of demands on the social side. It's of course about molecules and electrons, as many of the speakers have said today, but it's also about men and women, about how to prepare the workforce to this new economy which is looming, and that must be low carbon. And to be as concrete as possible, we have, as Industrial Europe, tabled a series of amendments in the context of the Fit for 55 debates to try to create social conditionalities where industries to get support, for instance, in terms of state aid to cover the impact of ETS on electricity price, or also to get access to free allowances, those companies would have to negotiate plans with trade unions in the company for each site to anticipate and manage the structural change in a socially fair way, including in terms of skills, in terms of training for the workers. We know, thanks to a series of our affiliates, that in many cases, companies do not have structural plans to anticipate what the industrial change means for the workforce. this is a major issue, and this is something we would like to fix with the amendments we have proposed in the context of the Fit for 55. But in a nutshell, we need more policy planning, more resources, and more workers' participation to better anticipate change for the workforce.
Okay, then over to Wim. Are you as a trade union already structurally involved in discussions on industrial policy, industrial decarbonization? And what, in your view, could be done to better engage workers in companies and on sectoral level in the transition?
Okay, so I think the key word is here involvement. We as a union, we want to be involved, more involved. And when I look at Belgium, there are already some examples of where we are involved. We sometimes have an impact on the policy made by our policy makers, for example. But at the sectoral level, at the company level, which are the most important levels, there is no structural social dialogue on climate change this day. So we as a union, we are very active on the team. We think about it, we have a vision. Our employees federations also, employers federations also, and we invite each other on our events and so on, and we can tell our ideas, and they can tell their ideas with us. But there is no structural dialogue where effective decisions are being made. How can we together make sure that the climate transition in the company, in the sector, is getting in effect? Can we make concrete agreements? That is not the case today, and especially not in the companies themselves. And I hear this also a lot of our representatives. We have some companies that are undergoing a big transition. We have ArcelorMittal, for example, who is also doing a big investment in decarbonisation, and they get the information. They are being told, okay, we are doing this and this this investment, but they have a lot of questions, skills, training, impact on the job, and so on. And there is no real talks about that. So the example of Tata Steel, which is for us a very important example, this is not the case in our steel industry as of this day. So we are asking for more involvement, but we are also aware that we as a union have to be also more proactive, because we have the tools. We have the tools to talk about these kind of things with employees and so on. With employers, but we do it we do it not often enough. So we as a union, we struggle with it also, because one, it's most of the time very technical. We do not have the knowledge, always the knowledge that is needed to talk about these things. It's also a question of means, of people, of time. And like you said, our members are busy with other things in their companies. For example, now the energy crisis, and so on. So it has to come from both ways. We have to be more involved, but we should step up also and be more proactive in demanding that we are going to talk about transition in the companies.
And perhaps to Bas, do you think that it's important that trade unions are involved in discussions about technology? We have been discussing a lot about technology. Isn't that too complex for trade unions, or, in your opinion? Well, I mean, just because it's not of their priorities right now.
Yeah, I don't think it is too complex. I think we make it too complex. I think the workers who are doing the work every day understand the processes better than anyone. And they also know what works and what doesn't. So if you take them serious, you can have a very engaged conversation. That's also what we saw at Tata. So the cooperation between the workers on the one hand, scientists, environmental organizations, and that's why I think we have to work together. No, as trade unions, we do not have all the technical knowledge which we want to have. We do not all the time, do not have all the time we want to have, but that's why we work together with environmental organizations in the Netherlands, such as Natura Milieu, but also Milieudefensie, Friends of the Earth. And on those climate plans, which are absolutely vital, company climate plans in line with the 1.5 degrees goal. Fascinating thing is that our government never asked those the most important companies for such a climate plan, and it's only as of recent that Milieudefensie, Friends of the Earth, asked 29 vital key players in a transition for a climate plan, and the good thing is they all delivered that plan. Bad news is that none of them was good enough. So we have a lot of work to do to have that seat at the table, and yes, we have to step it up. But I think the cooperation with other social and environmental organizations is essential to do that.
Okay. Then to Sophia, perhaps can you identify a bit what is perhaps a good example of how a just transition should be shaped? Have you examples of companies or sectors where there is a good example of what should be done?
Yeah, I don't have such a good example like you have with Tata Steel. It's really interesting. But we have also, like the Germans in the room know what I'm going to say. I think we have the big, it was just, I think, 2019, when we had reached a big, like peace on a big conflict. We had like the coal phasing out, and the lignite coal phasing out, and it's about the mining and also on the power plants. And we had a quite good instrument. We found a good instrument. We made a commission. Okay, that's not so innovative, but how it was set up. This was really a new thing because the government gave this away to this commission. And there were 28 people sitting together like 7 months, and it was also big in the news, and everybody was following it because it was a huge conflict in the last years, and also my union was really engaged in this, and it was about like 10 areas. It's called Reviere in Germany because we had a really big tradition in the coal mining sector. And this was about ending it and on climate matters and not on economic matters like in the black coal phase out we already have seen, for example, in North Rhine-Westphalia. And this was a huge thing because it was not made by the government, it was not made just by a small group of people, but of this commission, like 28 people together, also NGOs and politicians from the region, also from the higher levels, and also from like us and two other union members. And many people waited for the coming out, what we talked about there. And then the government, it was not one-to-one, but they most of it it was set in a legal process, and they made this. So it was really a good thing for us. So now, like, peace is done, and we could move forward. And I think this was really for processes we are facing for industries and also for the workers. So for us, it was about the workers, sure. And we had retirement schemes, and also like looking forward, commissions who are sitting in the regions and looking how the transition is done there and how it will be made sustainable, how new industries could be settled there. It's really a big thing to do, but yeah, I think this is a good example to get together.
So to summarize, perhaps, if you say to workers, well, coal mines should disappear, Workers are getting very anxious about this, unless they have an alternative which fits for them, for the region, is it that? And to have a view of where the region is going to in terms of new industries.
Yeah, they have a view, but also they have a view in a small way in their lives, because they don't just get money and somebody says, yeah, now you have money, so do what you want. But they get education, they get skilled. So it's a really, I think, a good program. Everybody agreed on how to give those workers, and also young workers, that there aren't only old workers phasing out, but also young people starting the new job and want to have a perspective. So, and I think they got a perspective for them.
Now, if we were talking earlier about circular economy, it means creating new value chains. It can be also in the hydrogen economy, in the renewable economy. There are new possibilities for some kind of industries, new jobs as well. And the studies say that, well, job perspective is not so bad in general, but it means also perhaps losing what we have now. How do trade unions see this complex issue of creating a circular economy with new value chains? Perhaps you, Bas?
Yeah. It is a transition, so it's never going to be as clean and smooth as you want it to be. But you do have to paint a picture of the future in which workers know that there is a place for them. So that's the thing we aim to achieve with the just transition principles. And if you can guarantee people there is a place for you, and we will help you with that next step, then I think people can also be and will be more optimistic about their own futures. Even though you're not 100% sure about how that's going to look like. But what we're seeing right now is the other way around. We do not try to involve people in what the future is going to look like.
Yeah.
And
that makes them anxious, perhaps. They know not. Okay. Do you want to add something?
Yeah, no, I think that we should also avoid to depict the picture in a too naive way. I mean, it's true that for a series of limited sectors, like coal mining, for instance, we are talking about phasing out. But for the wide majority of sectors in the economy, especially in the industry, we are talking about transformation. And we know as trade unions that technology transformation is never only a technology transformation. It entails a social discussion, because first it has an impact on productivity and therefore on the volume of employment. This is something which is in the core business of unions at company level. Then we have to talk about the kind of jobs we will keep in the industry. What kind of profiles? Do you need white collar, blue collar? What kind of skills? And what kind of retraining policies? And again, this is the DNA, the core business of industrial relations, daily industrial relations at company level. Then you can discuss the organization of work. You can discuss occupational health and safety issue. If you, I don't know, transform a blast furnace or a steel plant into a hydrogen-based steel plant, it raises a series of important discussions about notably safety of industrial installations. And all those issues that I briefly mentioned are usual daily business of trade unions in the works councils. Yeah. So that's why it's absolutely crucial that trade unions are not on the menu, but are on the table to discuss technological change at company level. And we had a series of examples, and we know that in some part of Europe we have well-advanced discussions, strong industrial relations systems, Sweden, Germany, sorry, and to some extent also Belgium and the Netherlands. But we also know as industrial Europe that there are a series of countries in Europe where there is basically no industrial relation systems, no institutionalized space and procedures for social partners to deal with those issues. And so that's why we also need to have an EU-wide just transition framework to ensure that the kind of way to manage and steer structural change, which is happening with good and bad examples, but it's happening in the west-north of Europe, will also happen in other regions of Europe, south and east. It's absolutely crucial. And it will not fall from heaven. We cannot bet on the goodwill of multinational companies. It has to be enshrined in law. We have to create legal obligations for companies to negotiate with their workforce.
Okay, my third question was in fact, what is the role of trade unions? I'm aware of the time, and that perhaps the most important things or have already been said. How do you see the role of trade unions? Perhaps 2 minutes, who wants to add something to that? How do you see your own role as trade unions?
But I think I already answered that question. The role of the trade unions is to be, in the first place, is to safeguard that the transition to circular economy, sustainable economy, is a just transition. And I think it's also very important for us as a union to say that this transition is a good story for us, because we know that by becoming climate friendly and so on, we will strengthen our industry, we will create new jobs, we will safeguard new jobs. So that's a very good view that we have on that case. All that we want and ask is to be involved, so that we can talk with the direction of a company, make plans, make concrete engagements, and also, like I said before, that we have to take that role ourselves more proactively than we are doing today.
Okay. Yeah, I think for us in Germany, it's like it was the whole years now. We are doing this transformation topic to. We will push for the keystone to get our really high energy-intensive industries carbon neutral, and that is to get the rollout for the renewables, because we are really delaying. We don't know how to have our sites here, because we need the green energy, and that is what we will do, and that's what we have done. So we try really to push for the infrastructure, so that we don't have the carbon leakage. And the other thing is we will also push for investments in to have like solar panels and the other thing. But you can't really make the mistake to think, and I think I have heard this before, like, yeah, there will be new jobs, and the people who won't work in this like cement or glass industry, they would just go to this industry. No, that won't happen. There are also people, and we really need to take them serious, as we take the people serious, like when we talk about acceptance of civil society. So, as Benjamin said, we really need to make progress also on the EU level, to have a framework for just transition. So, and so that we have like the transition crossed with education and also with qualification and social guidance.
Okay, thank you. This is all we have time for. Sorry. Then over to the public. Your questions you can ask to the speakers. Okay, go on.
Thank you. Jonas Helstedt from Bologna. Thanks to all of you for being here today, and I really appreciate this conversation. I think what you've been saying here is absolutely crucial. We need to make sure that this is a social transition as well as a climate transition. And as Benjamin said as well, this is about jobs on the ground and people. I think that's been resonated across the panel. I had a specific question to Wim. You've been talking a bit about the Tata decision in the Netherlands and about how that also, your engagement also was important in ensuring the future of the jobs. I think that's a key aspect. Often we hear industry in the climate conversations, at least we as NGOs, threatening with moving somewhere else. But for unions, that's not an option. These are people who are working there. I think that's really important that you're involved. But the Tata plan, of course, relies on hydrogen and supply of hydrogen. And from what I've seen, both from the press releases around it and also the conversations in the Netherlands, it was supposed to rely at least for a transition period on gas until hydrogen is available. Now, I think there's some reason to be worried about the feasibility of that. Of course, the gas is not there anymore, and the hydrogen as well. So how do you see that from your perspective, please? Thank you.
Yeah, so that is a risk, and the coming few months have to prove how feasible Tata's plan is going to be. I mentioned the talks with our Ministry of Economic Affairs, which are going on at the moment, talking about the infrastructure needed to provide the gas and hydrogen which is needed. But it also means, it was already mentioned in the presentation, we will have to import hydrogen. And we do not have unlimited amounts of hydrogen. So we also have to choose, our government has to make a choice on how to spend. So Tata is one of the first which has their plan kind of ready. But there are probably also other players in the industry which will need those types of hydrogen. And that's a difficult part because you don't have plans at the same level of readiness to evaluate and make the best decision about where to invest that limited capacity. So yeah, we see that, but it's also due to lack of industrial planning by our government in the past 25 years and leaving everything up to the markets. And now in the coming years, there have to be strong choices. There are strong choices to be made.
Okay, other question, Mark.
Yeah, Mark Alexander, Nierstar, ACW. I would like to ask a question to Dennis. When you were saying that now in the first step we need to take care that the energy-intensive industry is not going to go away and take the measures for that. Is there no danger that when we will do this and postpone a bit the other things to a second phase, that we will miss the opportunities that will help us to come through the first step? Because now some of the technologies which were not economically viable are becoming it because their concurrent gas and fossils are becoming so expensive. And so is there no danger that we will waste hundreds and hundreds of billions of euros in Europe by just helping the OPEX of the actual flow sheets in industry and households in place of investing on both levels, industry and households, immediately in the alternatives? So this is a bit my question, because it's not all of the alternatives are at an early stage. Some are really just before the valley of death and can go more easily through it in this time, when financials are used in a more clever way.
It's a personal opinion, but I think that we are on the same page. When I said steps, I was not referring to, I don't know, some kind of decade status quo. The idea is to think about all what we need to protect the energy-intensive industries in Europe. Commission should publish today or in the coming days first a communication complementing the previous ones and detailing what could be done in terms of notably decoupling electricity price from gas price. I think that this is the kind of urgent measures we need to shelter or protect or defend as much as we can energy-intensive industries in Europe. The list is not exhaustive. There are other mechanisms that should be or could be proposed, such as price caps and so on and so forth. I will not detail them, but these are the kind of urgency measures I had in mind when I said step one, protect the energy-intensive industries in Europe, because again, once they are gone, usually they do not come back. And then I think that I fully agree with you. We need to look forward and to be sure that we keep the policy compass in the right direction. And the right direction is the European Green Deal objective, and to be more precise, the EU climate law objectives, carbon neutrality in 2050 and minus 55% for 2030. And it's again a personal opinion, but I think that the investment choices that will be made by companies and member states in the coming months and years should keep that policy compass in mind. It would be indeed a strategic mistake to waste billions into technologies that we know are incompatible with the climate objective or climate science, to say it short.
Thank you, Benjamin. And thank you for all the speakers and for Jeroen for guiding this discussion. I want to thank also the audience. You were a great audience. Thanks for participating and asking a lot of questions. Now we can go to the foyer to have a drink, to have a beer, to have a wine, eat some nuts, and to talk a bit more about this topic or about something totally else. That's up to you. I'm very happy that you are here today, and I hope to see you again next time.